Somebody has lost a wallet. It has been found. There it is. If that is your wallet, please come to the registration desk to claim it. Secondly, T-shirt sales close at 4 p.m. today, so go get them. But not right now, because right now I have to introduce Aaron Fisher and his talk on the colony reputation system.
Hello. Hello. So I want to talk about the colony reputation system. Just going to wait for the slides to appear. Here we go. So you may know Colony as a platform for organizing teams, collaborating online, doing work. And that's very much what we're about. It's to use the blockchain to help us work together on projects that we care about. We like to think of ourselves as the people layer of the decentralized application stack, meaning that we're very much a blockchain company, but our view of the world is not something like this, with the blockchain front and center and people sort of as an afterthought of the periphery. It's about using the blockchain as a foundation to help us coordinate and really do projects that we care about, that teams care about, helping them work together. To that end, we want to create a platform for self-governance without a strict hierarchy that's flexible in who controls and who influences what goes on. And for this to work, we have a reputation system that allows us to weight our decisions. It's not about voting per se, but it's about people who put in a lot of work and a lot of effort, earn reputation, and then they have more say in the project at hand. So, what is reputation? And reputation is fundamentally something subjective. It's sometimes hard to pin down. And we often talk about reputation in terms of reputation scores. And so these here are not reputations. These are scores that might convey reputation, that tell you a little bit of information. So you might like a movie with a high tomato rating. It tells you a very specific thing. And what that means to you is still subjective because you may trust IMDb ratings more than the tomato ratings. And the information in each one of these ratings is very specific. Reputation really doesn't translate. So, if you have a high credit rating, which is a type of reputation score, what does that tell you about how good you are at tuning pianos? Very little, right? Reputation requires context, so it has to be more than just a single number. Like, we cannot have, it just doesn't translate. So, the reputation system that we're working on today is what I want to talk about. It's not just a number. It has to be more complicated. It keeps track of a lot of things. Your activity in the colony is what determines your reputation. So it keeps track of the work you do, but also in which domains. So domains are like departments or working groups within a colony. It keeps track of what skills you used, what type of work it was, how much you earned as a proxy for how big the work was. Was it a huge task or a little tiny fix? How well you did your work, what the other people thought about your work, and more and more and more. So it's very complicated. It has to try to keep track of all of these different aspects. So as an example, suppose in our colony there's this task called, give a great talk. And in our interface it might look somewhat like this. So you can see up there, I've been selected to do this task. There's a bounty of 100 tokens for it. And it's been tagged with the public speaking skill, the communications domain, which is our communications department, the Devcon3 subdomain, which is our working group for preparing for Devcon3. And if I do this task and I do it well, then I'm going to earn 100 tokens in our colony, but I also stand to earn reputation. And I will earn reputation in the skill, public speaking, in the domain communications, in the Devcon3 working group, and so on and so on. And how much I earn still depends on how well I do. The 100 tokens give us a proxy for how big the task is, but if you give me a standing ovation at the end of this talk, I can upload a video of that, and then I earn extra reputation points for having done really well. So I'll get back to you on that later. The reputation that I earn helps us in the collective decision making, and what we want, so this system is a Sybil-resistant decision-making mechanism. You have to actually do work to earn reputation. It's also meritocratic, not plutocratic. I mean, what we mean is you have to do good work that your peers like to earn reputation. It's not something you can buy. So it's not the person with the most funds who has the most say within a colony on this level. And although I'm not going to go into it too much, I want to emphasize this is not about repeated rounds of voting. This is more an implicit decision-making mechanism, and votes are just of a last resort. So it's not bureaucratic. And we use this for almost all day-to-day decision-making in a colony. That asterisk, by the way, refers to our last year's talk at Devcon3 about token-weighted decision-making, which still has a place for questions concerning tokens. So token holders must have a say when you're deciding to dilute tokens, but for the day-to-day activity, it's your reputation that counts. So you can get reputation, as I said, by working on tasks, but also doing administrative work. Administrating tasks, evaluating other people's work, all of these things could earn you reputation. And also policing the colony. That is, if you see people abusing the system by creating wasteful tasks, if you go around flagging those, that might be valuable. You can earn reputation for doing that. If you abuse that system and somebody else flags your flags and essentially initiates the dispute process, they could also earn reputation. So we're trying to balance all these different actors. And if you participate in the reputation mining procedure, and that's something I will talk about later in this talk. So reputation is an amalgam of all these inputs, and it has to be this complex, or let's call it nuanced, to be useful. So to be truly useful, we wanted to keep track of all these different aspects. So the question is this too complicated? And what I mean by too complicated is that on the one hand, we've got meaningful reputation scores, and they're competing with the gas cost, right? The more complicated the calculation is, the more it's going to cost to interact with it on the Ethereum blockchain, and that might make it less useful. But even more so, we're competing with the gas limit, right? There's a maximum cap for how complex our reputation update calculation can be. And I'm going to let you in on a secret. What we're trying to do far exceeds the gas limit. Like, this is not something we can do on-chain. So, does it really have to be on-chain? Does reputation have to be on-chain? The easy answer is yes, of course it does. If you want it to have any effect on decision-making in a decentralized context, on payouts, anything of that sort, it has to be on-chain because it's, what's the word? It's consensus relevant. But our answer is it doesn't really have to be on-chain. Like, it's not necessarily to do the calculation on-chain. As long as you can prove to the smart contract what your reputation really is, you don't have to do the rest on-chain. And the system I'm going to describe scales nicely because no matter how many colonies, domain skills, or any other tweaks we put into the update formula, we're only going to need 32 bytes to be stored on-chain. So the way that works is the following. We have all of these reputations here. So maybe R0 down there might be my reputation in our colony for the public speaking skill, and R3 might be, I mean, these are all the different reputations. If they were on the blockchain, the contract could read them. What we do instead is we hash them. Now, if those hashes are stored on the blockchain, then the contract, of course, would not know what my reputation is. But if I supply my real reputation, R0, in a transaction, the contract could hash it, check it against the stored hash, and then it would also know that what I'm saying is true. And the next step should come as no surprise. In this conference where Merkle trees are mentioned 5 times a day, we hash them pairwise and pairwise and pairwise until we get to a single hash, and that's the only thing we need to store on-chain. And referencing that, anyone can prove what their real reputation is. So the only thing we left to do is figure out a way to calculate the reputation root hash and to submit it to the blockchain. So how does it make it to the blockchain? And that's this reputation mining procedure. So anyone can calculate the correct root hash. Everything that goes into changing reputation happens on-chain, completing a task, administrating a task, taking part in the colony. So calculating it is not that hard, but we need to figure out who can submit it to the chain and make sure that the submission is correct. So the first ingredient is a little bit of game theory. You can earn funds by submitting the hash, and you can get punished for being wrong. And for that to work, we need to be able to prove something wrong. So the key insight is you don't have to be able to do the calculation on the blockchain and figure out what the correct hash is, as long as you can prove that a wrong hash is wrong and penalize the submitter of the wrong hash. So suppose you want to take part in reputation mining, you just simply set up your mining farm. Actually, no, you just take your laptop, all you need, it's a small calculation. In the off-chain world, it's only hard in the context of Ethereum. You need to stake some tokens. Our colony tokens are needed to become a miner. Then you run the colony mining client. And the colony mining client will monitor the Ethereum blockchain and collect all of the little events that happen that influence your reputation, apply that to the reputation tree, figure out the correct new root hash, and then submit it to the blockchain. Having said that, all miners, of course, want to be the one to submit it to the blockchain, and we don't want to spam the network with too many submissions. So there's this competition going on where at the start of a submission window, very few miners qualify, and as the time goes on, more and more miners qualify until all the submission slots are full, and then a new cycle will start. Yeah, and then miners earn tokens. Earning tokens is the paradigm in this space, so that's no surprise that happens here as well. And so that's the overview of this mining procedure. And I want to say just a little bit about this CLNY token so that you don't get the wrong idea by thinking this is all it does. Any colony has a token to do its internal accounting with. And the CLNY token is a token of a colony, the so-called common colony, which it's a special colony. It's the one that's responsible for managing the colony network. Now, once we're launched in a fully decentralized way, we don't want to be, like us as a colony team, want to be responsible for maintaining the network indefinitely. We also want to keep that decentralized, and there's a special colony whose role it is to maintain the contracts and so forth. And it's this colony's tokens that are used in the mining procedure. All other colonies pay a small network fee to the common colony for the services provided, the maintenance of the software and also the mining. And if this network is profitable, if the common colony is profitable, people who hold tokens and reputation could expect a payout. So there's an economics involved in this entire network. That's more detailed in our white paper. Okay, so let me talk about what happens if someone tries to cheat. For our reputation mining to work, all we require is a single honest miner, which is good. But if there are several submissions, then one of them, all but one of them, we assume are wrong. And how do we determine that? So if there's two submissions, both parties have to submit a justification for what they've submitted, which takes the form of another hash, the justification root hash. And these indices down here are all root hashes of a reputation tree. So RH0 down there, that's the root hash we agreed on at the end of the last cycle, so we all agreed on that. And this one down the other end is the one that the miner submitted, the one they claim is the new root hash. And each step from RHI to RHI plus 1 represents a single update of a single person's reputation applied during the update period. So if we agree on the very left and disagree on the very right, at some point there's a first step where we disagree. And what the contract does, it challenges parties to prove the inclusion of a single specific reputation update step, which is small enough to calculate on-chain. And by looking at the Merkle proof, it can determine where the discrepancy is, and after a few iterations, either one party will have to stop responding because we found out that they cheated, or we actually determine a mistake in the calculation. So the wrong hash gets discarded, and whatever is left in the end is correct. And this is fully automated. So if you run our mining client, you will never have to deal with this. This is all completely automatic. And it also doesn't require a challenge-response protocol of different actors. The challenges come from the smart contract and is fully automated. And that's because the reputation update, while not being able to be done on-chain, is completely deterministic based on inputs from on-chain events. All right. We released our white paper recently in September, which just goes into this whole process in far more detail and also describes the economics of the network. So why did we spend so much time on this? We spend so much time on it because reputation really allows us to fine-tune the incentives. We've heard a lot about crypto economic incentive systems, and they often involve paying people to do things or penalizing them financially to try to get them to behave in a certain way. But the reputation system also allows us to reward and penalize people in a not immediately financial way. And we can really fine-tune what we mean by good behavior and bad behavior and tweak that as we see fit. And that's especially important because in this context of trying to avoid voting on everything, we want colonies to be very fluid, where, for example, if a task is created and I say, I want to do that task, if nobody objects, it will happen. There's no need to ask my team members. So if you think of the teams you're working in, most of the time you are in agreement amongst yourselves, and if every little action required a vote, it would be a horrendous headache. So it's designed not to use that. And if somebody goes in and forces a vote all the time, they might actually lose reputation based on abusing the system. If you do it in just those moments where it really counts, the system could pick up on that and you could be rewarded. So because the calculation is off-chain, we can make it as complicated as we need to really fine-tune all the incentives of the actors in the colony. And it's much more than we could ever do on-chain. And yeah, one of the aspects that we really can't do on-chain is the concept of reputation decay. So reputation in a colony is not forever. You earn reputation, that means you then have influence in the colony, but over time that influence decays away. And that's a protection against people early on in the colony amassing massive reputation. They have a lot of influence, but it should not last forever. So when you join a colony later, you can assume that the people with the most influence now are the ones who did the most work in the recent past. And that really evens out the imbalances over time. So we think this is a key feature. So back to the task that I'm working on right now. When I upload the video of your standing ovation, I'll get points for that. For the talk last year at Devcon3 with Elena, I still have some points because that was relatively recent. Jack right here gave a talk at Devcon1. His points have completely decayed away. If he wants some, he should really come up here and tell us some more about colony soon. Thank you. So in summary, the points are earned for doing good work, and good is something that we can tweak and fine-tune to get the incentives right. And the reputation weighs your decisions all throughout the colony, but we try to keep them as local as possible, again, in the interest of making things as unbureaucratic as possible. Keep them within a small team, within a department, and don't always go to the full colony for every little decision. And maybe, importantly, I haven't mentioned yet, reputation doesn't translate from one colony to another. And that's because there could be many different colonies, and we have no idea what there's no way to translate from one to the other. What it means to do good work in one colony might have nothing to do with another. And it relates to the various tokens. So if one colony does great work and this token is worth a lot, the numerical values of the reputation might be quite low. Elsewhere, they could be completely inflated and meaningless. So it's within a colony, but the reputation mining process updates everyone's reputation in all colonies, in all departments, in all skills. So that's one global system within the colony network. This is our team. Our team has grown quite considerably over the last year, and this photo was taken at our last offsite. And in fact, it's already out of date. We've added more people since then. It's a great group of people. Really glad to be part of this team. So I want to leave you with our advertisement for our blog. The blog.colony.io has a lot of good content that goes beyond just colony. We write about regulatory aspects of token sales, of sharing, of equity agreements in this decentralized space. There's a lot of good content. Please do check it out. Find us on Twitter at JoinColony, and I'm now ready for that applause and ovation to prove that I've completed my task. Thank you very much.
Ethereum's a unicorn! Woo!
Hello. The next session is Building a Decentralized Court System to Arbitrate Smart Contracts by Clément.
Test. Okay. This one not okay. The mic works. So, hi everyone. Can you remove the? You have a mouse on the screen. Can you remove the mouse on the screen? Thank you. So, hi everyone. So today we're gonna speak about arbitration of contract and decentralized courts. So first, let's start with a simple example. You have Alice and Bob who met on a freelancing platform, and they agreed that Bob will make a website for Alice against 3 users, and Alice pays Bob. But Bob gives a shitty website, and Alice is not happy and wants her money back. But since there is no chargeback with crypto, she has no recourse. So to avoid that, she could put money in a smart contract. If she gets the website, great. She signs, and the contract pays Bob. But in case of a dispute, Bob says, no, I've made the website. If you want something better, you'll have to pay extra. And both think that they're right, so they pay arbitration fees. The dispute goes to an arbitrator, and the arbitrator can rule, which will trigger the previous smart contract, which will move the funds. The first catch is how could the arbitrator know what this smart contract was referring about? So to solve that, they first, when they create the contract, input the hash of the plain English contract. And this way, when there is a dispute, they can show to the arbitrator what was the contract agreed in plain English. And if there is no dispute, it's privacy preserving, and no one has to ever know about what the contract was. Actually, we can even do better. Imagine we have a contract with 4 pages. Pages 1 and 2 are on one topic, pages 3 and 4 on another one. And you don't want to reveal both of the topic of the contract if you only have one topic which is important for arbitration. So use a Merkle tree, and you just have to reveal the pages which are linked to what you are disputing. And the thing is that the arbitrator can be everything. It can be a centralized party, a multisig, or even a DAO. And that's what Kleros is. I've given an example which is really simple, which is just transfer money. But in practice, we can have way more complex dispute and enforcement as long as it's enforceable by a smart contract. So with money, with freelancing, e-commerce, crowdfunding, you have all those ICO, there is money, but if the token buyer are not happy, they have no way to get the money back. So we could have milestone, and when a milestone is reached, you unlock the money. And if the token holder and the team don't agree, that's a dispute. Online gaming, cheating, social network, you submit content, which is against the chart, you have a dispute, you lose, you remove the content, and you penalize the party who are violating the rules. Intellectual property, we've seen a nice example in the Devcon with ENS. You have someone registering your trademark. Well, you go to ENS system to have blacklist. You have a dispute. The dispute is, okay, this is my trademark. I don't want you to use this ENS, and I want it to be blacklisted. And the result of the arbitrable contract is a blacklist of the domain if the one claiming the intellectual property is seen as correct by the arbitrator. Or insurance, did this event occurred and does the insurer have to pay? So we can abstract that and have two kinds of contracts: arbitrable smart contracts, which are responsible for enforcement of ruling, and arbitrators, which are responsible for giving the ruling. And the goal is to have every arbitrable smart contract arbitrable by every arbitrator contract. So this way, if you're a contract developer, you can easily switch from one arbitrator to another. So let's go back to Kleros. The idea of Kleros is to have crowdsourced jurors. So first we could say, okay, we let everyone register and everyone is a juror. Well, that will be quite impractical because you will either need to pay everyone arbitration fee or everyone will get peanuts. So in both ways we have an issue. So we can just draw some of them which will look at evidence and vote and get arbitration fee, but not all. But there is still a problem. Since we don't have a way to be sure that someone has just one online on-chain identity, someone like this guy could register tons of time and be almost the only one drawn. To solve that, instead of drawing jurors, we draw tokens. So you activate your token for arbitration. We get a random number with one of the methods I talked about yesterday. From this one, we can get multiple ones. Everyone who has a token drawn is an arbitrator. So we add the incentive to arbitrate, which is get the arbitration fee. But now we need an incentive to arbitrate correctly and honestly. But unfortunately, we can't really measure honestly in an algorithmic manner. We could say, okay, it's another dispute. Did this arbitrator rule honestly or not? But that's some kind of chicken and the egg problem. So the best thing we can have is coherence as a proxy of honesty. So in this example, Ignacy and Julio, they voted for Bob, while the majority voted for Alice. So those jurors, they will lose part of the token to the juror who voted coherently. That's inspired by game theory and shading point. In this basic example, if you vote the same way as the other, you win something. Otherwise, you lose something. And if we remove all the label, we can see a matrix which is symmetric. And from a mathematical standpoint, there is no reason to vote for Bob or for Alice. Both of them could be seen as the same. But fortunately, we have labels. And in the absence of other factors, we have some solution which can emerge, which we call the focal point. And in this case, the focal point has to be honesty. So why would you vote honestly? Because you think that the other will vote honestly, or perhaps because you think that the other think that the other think that they will vote honestly. In practice, it goes up to 3 levels. And that's how we can get honest rulings. There are still some attacks. One could be, okay, I vote before everyone else. I vote Bob. No, both of the other parties, they know that if they vote Bob, they are coherent. So even if Bob is not the honest answer, they could vote Bob. So how to avoid that is to use commit and reveal. So instead of voting directly, you generate a number, a random one locally, and you commit the hash of this number and you vote. And in the second phase, you will reverse the number, you vote, and on chain we can verify that it was effectively corresponding to the hash you submitted. You could still say, okay, I'm going to reveal my number and my vote to the party to influence them. So to avoid that, we have to penalize this behavior. So if someone reveals the number and the vote to another party, this party can show that on chain, invalidate the vote, and steal part of the coins. So this way, you can't influence others trustlessly. You can either say, okay, I'm going to vote for Bob, but I don't prove it, I don't show you, I could be lying. Or you can say, okay, I'm going to vote for Bob, I show you the proof, but now you have the right to steal my coin and invalidate my vote. So it's not trustless one way or the other. Another attack problematic will be bribing. And that's particularly problematic with blockchain and smart contract because you can make bribing smart contracts which are trustless, which will automatically pay the bribe if the juror vote the way you asked. So to avoid that, we need to have an appeal system. So if someone managed to bribe juror at some level, the other party can appeal and get more and more jurors. And if we are in the honest majority assumption, it will be highly more expensive for the dishonest party because most of the round he will lose, and even in the round he will win. He will also have to pay bribe, while the defender just have to pay appeal fees. So that gives a huge advantage to the defender. Another problem which can arise is, okay, perhaps I don't like freelancing dispute. I don't want to arbitrate those. I want to arbitrate insurance. So for that, we need an arborescence of courts which are increasingly specialized. So when you register to be a juror, you don't just choose a court, you choose a pass to one court. So for chief, it's general, e-commerce, and freelancing. So it can be drawn in all of those. But we can ask, okay, how do we make other court? If we were to let everyone make subcourt, that will rapidly end in a mess of subcourts with no coherence. So that's why we need governance. And we've seen in previous governance systems, like the DAO, that we have a huge problem, which is most of the token holder, they just don't vote. So how can we count the vote of people who don't want to vote? That solves through liquid voting. So in liquid voting, either you vote and everything works as if it was in direct voting, or if you don't, and you've designed before, and you've chosen before an advisor, you vote the same way as your advisor. And if this advisor hasn't voted, but also as an advisor, you vote as the way the advisor of your advisor votes, and it can go to the point that you have one party who is effectively voting. And now we've seen the website dispute, and we see we have tons of website dispute. So why not make a court specifically for those? We can also have some other kind of problem, which is it's arbitration. It's not just right or wrong. That could be the case for Oracle. If it's something, who is the president? Yeah, you either lied or you tell the truth. That's easy. But for disputes, it can be more shady. So where do we draw the line? If we just let jurors vote like that, some jurors will vote honestly, but be still considered as incoherent. They will lose token. They will be frustrated. So to reduce this problem, we'll have policies. A policy is something which looks like a law. It's basically a guideline of how to arbitrate. One example of policy will be if you sell some good and you sell it at distance and it's worth more than one Ether and you don't use track shipment and the buyer claims he has not received it, we assume that the buyer has not received it. So the one Ether, some party will say, no, we could do that for 0.1, 1 for 10, and it may not be consensual between the juror. So for them to know how they should rule, they should have guidelines which can be voted through governance. Another problem is the 51% attack. What if someone buys more than half of the coin and keep giving dishonest ruling, accepting bribe? That will pose a huge problem. That's also why we need some specific coin, because buying half of the coin of Kairos will be way more expensive as buying half of the Ether, which will be used in Kairos because of market depth. If you want to buy half of the coin of one coin type, you don't just have to pay for half of the market cap, because okay, the first seller, you pay them market price, but you rapidly run out of seller at market price, and the price increases. So perhaps even with a value which is higher than the market cap, you may not even be able to buy half of those. Moreover, if you buy those coins, you do some attack, and you accept bribe, you are dishonest, well, you end up with a dishonest court. And who wants his dispute to be arbitrated by a dishonest court? No one. So your token will rapidly become worthless. You can fork it even, and make another court with only the honest party. But even in that, there is still a catch, which is a contract which were created before. They don't know the court becomes dishonest. They don't know that they have to update to a new court and a new token, and they will still be under the arbitration of the dishonest court. But one could argue that it's the same with Ethereum and connected object, blockchain aware. If someone buys half of the Ether and 51% attack, all the objects relying on blockchain, they don't know there is an attack, and they will still behave the way the attack chain is behaving. And in the first step, I've shown you some really simplified version of what the incentive could look like, but in practice, it's way more complicated. So you have some part which is the token redistribution, voting the same way as the other. You also have the honesty of the decision. Because if the court gives honest decision, your tokens are a token in honest court, and honest court is valuable, so the value of your token increases a bit. And if the court gives a dishonest ruling, your value decreases a bit. And since the tokens are locked during the cases, you have no way to sell them before. But there is also a catch in the other sense, which is you're not a computer. You can't just like get evidence, process them in 1 microsecond, and give a ruling. It actually takes time. You have to look at paperwork, at images, at argument of parties, and yeah, time is money, so it has a cost for you. So you could just say, okay, no, that may not be worth it. I will just vote randomly to get the fees. So depending to the value of all these variables in the incentives, we can have multiple points where a party could always vote this way, and each one will be as coherent as the other. But some will lead to dishonest court, some will lead to honest one, and some will lead to court just giving random results. So what we call those, it's Nash equilibrium. It's a Nash equilibrium when everyone's strategy is in such a way that after everyone knows everyone else's strategy, no one regrets his own strategy. And changing from one strategy to another does not have a lot of sense if you don't think that the other party are also going to change your strategy. So that's why it's really important that at the beginning, the court give honest ruling, because this way, no one will have an interest in changing just for him a strategy to a dishonest one. So how can we verify that it works? How can we verify that? It's with experimental crypto economics. So at the beginning, you don't link that to real contract with real smart contract enforcement, but you still have draw and still have incentive in terms of token redistribution. You take a set of disputes that you know are already solved, but that you don't reveal to the juror, and you look at what the result will be compared to what you call your own ground truth, which is the result of the dispute you had before. And you can use metrics, which are inspired by machine learning to evaluate how the ruling of the court is actually related to the ruling of your ground truth. So basically, you do machine learning, but with human as classifier. So thanks everyone for listening. If you want, you can contribute. We have a basic version of the code, some arbitrable smart contract. You can interact with contract on testnet, and we are still building the Web3 interface to act with you in a nice and user-friendly manner. Thanks.
Thank you very much. If anybody has seen my private key for 0xDEAD lying around, can you bring it up? I'd very much like all the money that's stored in it. The next session is building a decentralized sharing economy on top of Ethereum with Christoph Jensch.
Thank you. So let's wait for the slides. So slides are not up yet. Did you show the screen? So let's see. Okay. Okay, so thank you very much for having me here. It's an honor to speak at DevCon. So I remember I've spoken since DevCon 0, DevCon 1, 2, now 3, and I see the crowd is really growing, like doubling every year. It's really great to see the growing of the Ethereum community. So I want to tell a little bit about what we are doing at Slockit. So our goal is to build a decentralized sharing economy. And since last year I was speaking, a lot of things have happened. So we have done several projects. One which is worth mentioning is Share and Charge. This is a project we did for energy and helped building it. And this is a platform where people can rent out their private charging station for electric cars and let other electric car users use them. So it enables to help that we will have a lot more charging stations, especially in Germany. And there are already 1,200 charging stations live on a public Ethereum chain. And this is backed up by a large corporate, such as Energy in Germany. I think it's one of those rare occasions where a large corporate is using the public Ethereum chain to connect their assets to it. So I think this is a really great project. Another project we are part of is the Energy Web Foundation. You will hear more about it later today from a talk, so I will not go too much into this. Another project we did last year, we used the DAO framework in another setting, and at Siemens, it's a large corporate in Germany, I guess you all know it. There is a live DAO running there with a lot of people participating inside the Siemens company, so Siemens employees, and they are using this for donating to charitable causes. So it's similar to a charity DAO that they use the funds they gather together and make votings together and send it to some places. So we are working hard with larger corporates in Germany to make them use Ethereum and help them learn how to develop technologies on top of this. But this is just one part of what Slockit is doing. The more important part, in my view, is our work on this so-called universal sharing network. So what is this about? Our goal is to connect smart objects to the blockchain by managing the access control in a smart contract to see who is allowed to use certain devices. So we know that the number of connected devices is growing and growing. You have smart locks, you have smart plugs, and a lot of other devices. And we want to control the access to them via a smart contract, which can be a payment, can be another logic behind this. So let me show you the architecture of the Universal Sharing Network. So first, you have the USN registry. And this is completely based on the ENS. You could even say it is the ENS, because we just use a domain there, which then resolves to an access control smart contract. This is another part here. And the access control smart contract has the logic inside to rent, sell, or share things, or even pay as you use, connected to a payment channel, or just have a whitelist of friends and family which are allowed to use the object. But every smart device can be registered in USN with a nice human-readable name, and then pointing to a smart contract managing its access control. Of course, another thing you need is an access control device, because most of the smart objects do not have enough bandwidth and computational power to actually run an Ethereum even light node. So, and for those who don't have it, we have built an access control device which runs an Ethereum light client. It can run an IPFS node, and it runs a library for home automation, so it can be used to connect to all those devices at home. I will also come to this point a bit later. This access control device is then connecting to the smart device or door lock or other things, and sending a Bluetooth, Zigbee, or Z-Wave signal to control it. So that's the basic architecture. Then, of course, you have the mobile app. The mobile app has the purpose of managing the keys, helping with discovering objects. Could be something which you're close to through NFC or scanning in a QR code, or something you're not close to, just showing a map and you can discover those objects. So this is the general architecture. Now I want to go explain a bit more about each of those points. So first, the USN registry, which everybody can use. It is following the following format. So it has a device name, an optional device counter, because we often found that you use one smart contract to manage a lot of devices. You of course can have one smart contract per device, but it's not very efficient also when it comes to gas costs, and often you have one owner renting out several objects. So therefore you have the device name, optional counter, and then the contract name. And the contract name then resolves to the access control smart contract on the ENS. So it can look something like this: a city bike number 3 at a Berlin bike rental.usn.eth. This is the ID of this smart object, which would then be resolved to the smart contract and can be managed from there. So we're very thankful for Nick, who developed the ENS. It's really a great system, very well thought out and very usable today. So let's come to the access control smart contracts. There are a lot of different use cases, and you cannot have them all in one contract. So actually, those smart contracts have only one required interface, which is similar to the ENS. It's just a supports interface function. And there you'd say which interface are supported, which can be several, something like the rent functionality, which is the most basic one, where people can pay a deposit, use something, and when they are done, they return it, they get a deposit minus the costs back, and the costs go to the owner. This is one interface. Another interface could be to book something in the future, reserve something for you. You can have whitelisted groups which pay nothing or you can use it with a discount, or you can just pay as you use. And in this case, you can resolve to an address which is managing a payment channel. With this payment channel, you can pay directly without going through the smart contract all the time, and just pay as you use. So those are the access control smart contracts. The access control device, that's something we have played around with a long time. In the beginning, we just used Raspberry Pis. They are nice. We can use them for a lot of things, but they also have their weaknesses. It's just not an industrial-grade device, which everyone who has used them for a while knows the SD card can break and a lot of other things can break. And so we have chosen the Samsung RTX 7 as a very good chip for our use case. It has an 8-core 64-bit ARM processor. It has Wi-Fi, Bluetooth, Zigbee, Thread, everything on this little chip here. It has 1 GB of RAM, 4 GB of flash, and this is enough to run an Ethereum Light client very stable in this device. And also you can have the IPFS node running in this. It has enterprise-class security and has a hardware-secure element in it, which you can use for storing the keys, but you can also use an SMT32 on the chip to do this. Software, as I said, the Light client. We have open source home automation software running on it, and of course our USN access control logic as JavaScript or Node.js code. So this is actually the stuff. I showed it here a bit. Some of the devices. This is a 3D printed box where we have this in, and I will show you in a minute how this hopefully works in a live demo. But let's get to the user interface. So we think user interfaces are very, very important if you want to target mainstream. So we hired a very good designer helping us building a nice user interface. So let's have a moment switching to my phone here. Let's see if this works. So you should see the screen of my phone, which is connected. Seems like it has a very weak, there it is. I'm glad it worked. So this what I show you now is not the real life app. This is the design of the app, and afterwards I'll show you what we have built so far, which is about 70 or 80% of the stuff you're seeing here. So, but I thought it's important to show you also the design, to get a feeling of how people can actually use the system. So in the beginning, you have a screen showing you what's some filters like available now within 0.5 kilometers, certain kind of things. So if you go into this, it makes some suggestion. So let's say I want to drink something in the morning. Well, I'm not a coffee drinker, so I actually may want to have a bike ride to the office, for example. We can switch to the map view to see what's available in my neighborhood or close to me. And so let's say I then want to rent something. I can also search for stuff based on time or just based on which kind of object I want to use. So let's say I'm in the morning, I want to take a bike to get to the office. So I can go for bikes. I can check out for the current location. And it shows me several bikes which are close to me, shows the price, shows also when it comes to reputation, like how many people who used it actually liked it. I can then click on the bike and see some information about how far away is the bike, who's the owner, is he verified? So this person, for example, is verified as Keybase, but we are very open to also use other mechanisms such as Uport or pickups from Parity. It really doesn't matter. The user can see how he's verified and if he can trust the system or not, which features, all of this kind of things, and then you can click on rent. Here you can see how long do I want to rent it, 2 hours, or maybe even several days. Let's go for 2 hours here. When it comes to payment, of course, Ether is the preferred way of paying it, but we are aware that not everybody wants to use Ether as a currency to pay it. So we also say we accept Bitcoin or US dollars using PayPal or credit cards. And how it would work in the smart contract then is, someone needs to send a proof that the money is received. This also can be just the owner. If the owner says, yes, I received the money, I can call it a function in a smart contract says, yes, I received it. Of course, you have not all the features that you would have if you would have paid in Ether, such as the deposit is held by the smart contract and only released once you return it. Those features you only have, of course, if you pay in Ether. So if you go next, get a summary of what's the bike, the date, how long, the payment, including a deposit in this case, and then you can just click rent. So the rent was successful. I can then go in the view showing me all the stuff I'm currently renting, which is the bike. I also rented a place in a co-working space. So if I tap on the bike, it would open a screen to actually go in front of the bike, sending a Bluetooth signal to open the bike lock. So, but let's go, here's for example the office space, which I also can use. Let's say I took the bike, I did took a ride to the office, I'm in there now, and so what's next? How could you also use it? There's also a way of just looking for objects which are close to me. So I could check for QR code or even NFC. So I would click, let's say there is a nice 3D printer I want to use in the office. And once I want to use it, I go in front of the thing. It is login enabled, so you have a nice login logo on it. You go there, you click on the near field communication. It is showing a device because you're standing in front of it. It's a 3D printer. You can have a look and you can rent it. So this is just an idea of how this app looks like. And now I want to show you the version which we have right now. So just a moment, it's loading. So let's see. Oops. Okay, there we go. So there we have this map view. We are here in Cancun. Just scroll a little bit. So we of course put some objects here. So this is now the real app, and we want to use this microwave here. This is what you can see here. If I click it, it shows me the microwave, which I can then click on. It shows me the price, 0.01 Ether per hour. It shows me some features of the microwave, and I can now rent this lock. I can ask how long. It shows me the calendar. I just want to, with it 1 day, not too long. Say, even 9 hours is a long time. I can select the Ether account. I can, of course, have several Ether accounts in the app. View the summary. There's the microwave, the renting time, 9 hours, the price, total costs. Looks good. So I can now rent the object. This is sending now a transaction on the blockchain. And you can see this device here, those nice LED lights going up. So what this box is, in there we have this access control device. We have the power plug, power supply, everything in one box. The nice thing, what you can do with it, you can plug something in, such as the microwave, and then close it. It's actually key to change the stuff you plug in. You can actually would like to show a washing machine, because a washing machine is a really nice use case. It was just too heavy to get here. So that's why we choose the microwave. But you could think about like sharing a washing machine in a shared apartment. You have like 8 students living there. One guy is buying the washing machine. Every time somebody wants to use it, he pays. And it's just completely without even talking to each other or having a shared calendar or something like this. So if I now go on the view of the object, I can see all the stuff which I'm renting here. So let's go on the popcorn microwave, which I am renting. So it shows me turn on and off. So let's turn it on. Let's see if this works. This is a real live demo. Yes, it is green. So it got the signal. So let's use this and make something in the meantime. So this is the microwave which I just paid for using it, running. So let's show some other stuff. Go into discovery mode. You can also go look at the list of things. There are bikes. And of course, there is an apartment which I may want to rent. This is the Slocket apartment. Yeah, Wi-Fi is very slow, so the pictures are loading a bit slow. But this is an apartment from our hometown, Mittweida, Germany. So it's remotely now controlled. I can see the price, some features, where it is, and also, of course, rent this log. I can set the date from today until start here, those 3 days. Payment, I'm using Ether. Show me the summary. Yes, everything looks good. Can rent the object. So now it's also sending a transaction. This is our office in Mittweida, very nice place. So rent was successful, and now I have control over it. So this is the smart log you can see here. I can maybe put this a bit up. Oops, let's say this should not fall down. So we are using a Nuki smart log. So we are not a hardware manufacturer of smart logs. We use existing smart log infrastructure to connect to. So the smart log here is now, because it's not smart enough to run a client in there, we have this access control device here, which is just running one of those light lines connecting to the door lock. So let's see, if I go now on the Slocket apartment, I have control over it since I rented it. Just a moment, still loading. Let's see, yes, it worked. So this is right now locked. I can now push the unlock button. This will send a signed message to this box saying, I want to unlock it. And then the light client needs to verify that it actually did work. So nope, let's try this again. The Wi-Fi is a bit shaky. Yes, okay. Now the log opens, I can enter and use this apartment. Okay, and then later if I don't use it anymore, I return it so I don't have access to it anymore. Okay, so I think also the microwave should be done now. So I just thought, who wants some popcorn? Right here. Get some popcorn to enjoy the presentation. You're welcome. So let's get back to real presentation. Okay, it's a bit small, but well. So what I wanted to announce today is that we want to start the minimal viable product now. It's still not perfect, so that's not a public release of a product that everybody can use it yet. But if you go on mvp.slocket, you can register to become an MVP user and try the system out. So that's what we want to do now for the next coming month and get some feedback, optimize the system until we feel it's really stable. Those users, the MVP users, can use it reliably. And once we feel it's safe, then we are ready to release it to the public and everybody can use it. But please register the mvp.slocket and try the system out. So all of this cannot be done alone because we want to integrate with as much devices as we can. And so we have a lot of partners and friends, from smart lock manufacturers, also of course people in the Ethereum ecosystem such as Uport or EtherRisk and many others. So we're very thankful for all those people we can work together with. And of course also I want to mention the Trusted IoT Alliance, which we are part of, which are a lot of bright people which are thinking about how we can secure IoT devices today using blockchain technology by giving them, for example, identities, and that you can securely transact using the blockchain. And of course, last but not least, I want to thank my team. I have a great team of, I think this is an old picture, we are about 17 people right now, plus some students and freelancers, so in total up to 20, and working on the system. And I really have to thank them for building all of this. They're a great team, and I think the next couple of months, or next year, we can release something which everybody can use, and we have mainstream users renting out things and connecting smart objects to smart contracts. And I think this is something where Ethereum is very good at, because maybe mainstream users will not use Ether as the main currency, maybe not. But machines don't care, and to pay machines, this is something we can really use it for. And machines can verify the payment and act accordingly. That's something we want to build together with you. So thank you very much for your attention. Thank you.
Check. Thank you, Christoph. Next up, we have Vaughn McKenzie with Jack, a new engine to power the web of content. Give him a round of applause.
All right, that works. Hello, everyone. Good to be here. So, I'm Vaughn McKenzie. I'm from Jack. If anyone knows us, we are in the music and media space. The name of the presentation today is a new engine to power the web of content. And I just really wanted to start first by kind of acknowledging that, in terms of music, there are a lot of music blockchain startups in the space. I thought it would be a good idea really to just kind of recap why we're in the space and why we really think that music and blockchain really do make sense. And yep, clicker works. So, first of all, what is the problem? And I think that the way that most people as consumers experience music is that we just think of a song as an MP3. So when we play a song or we hear a song playing, we just think, that's a song, I play the song, that's all I need to worry about. The problem with music is it's very hard to figure out who to pay. And that's because a song is actually kind of complex. So let's say that a few people get in the studio and they start working on some music. You actually are creating a very complex ownership structure. The reason why is because a song, which actually is not represented in the music industry, they don't really think of songs. They have completely other terms to describe things. Songs are just for consumers. But you have this thing called a recording. There's a copyright in there, and that copyright is normally created when an artist makes a recording. So if I go in the studio and I record something, I create this thing called a recording, and that is normally owned by a label. So labels own recordings. And in compositions, you can think about recordings being the implementation of a composition. So a composition, or as it's called in the US, a work, is really just the nuts and bolts, the mechanics of how this song was made, the lyrics, the melodies, and so on. And that's made by writers, so producers who make the instrumentals, or obviously the people who just write the lyrics. And that's normally owned or represented by publishers. And every single time a new publisher or writer comes onto a track, so you could have 5 producers, 10 producers, 5 samples, all of those things have their own ownership structure. These are like micro businesses. Every single one of these are they're argued by lawyers and figured out by managers and accountants to try and create this structure, and nobody has a real picture of how this works. Now, this is one song. On Spotify, there are over 30 million songs. So you can imagine how complex that is to try and keep track of. And the way we keep track of that is with proprietary databases. Now, this tries to explain how, when we think about how music goes from people in the studio creating it all the way through to a consumer listening to it on the other side, it's actually quite complex because a song itself is a collaboration. It's then pushed and the metadata and the music become separate, as they always are, and then they move down the supply chain in different ways. Now, on the work side, there is a standard identifier called an ISWC, and on the recording side, a standard identifier called an ISRC. And people like to apply these things willy-nilly. So they're just applied all over the place, and they don't really map down to the actual unit we're trying to describe. And as we want to keep sync between these databases, we create these exports, and we just send them around. So there's these flat files flying all around the industry, and this is what we're kind of using to sync, right? So in order to figure out who owns what, we're just using these flat files. Now, as we were saying before, the problem here is that we end up with complete information asymmetry. One person saying one thing, another person saying another thing. The only way to keep those two things together is to send this flat file. And that means there's fragmented content rights across all of these databases. And that means that even inside one organization, which could be global and own and control different things and assets in different territories, it's quite hard to keep an internal consensus in that company. And really, the only way the music industry has known how to solve this is just to create a new database. So we end up with more and more and more fragmentation, and really, we ended up with more and more databases. And then we end up with parallel data reconciliation. So again, most things are traveling around via XML and spreadsheets and getting delivered to FTPs. There's not very many APIs either. So actually, syncing is very much manual, and that's problematic because we are using proprietary databases, and access is ownership. If I want to tell you what I own, I have to give you the data. So it's quite hard to build out kind of one single database. However, one day the music industry did try to do that. There was one big global database, and it didn't really work for reasons we won't go into, but centralized governance is problematic. If I have ownership, I have control. And really, that's why blockchains are great solution to this problem. They help us avoid it. We have a network of unbounded parties. We have the need to collaboratively maintain a single data set. And we want to do it without putting in a central authority. This is why blockchains are a great fit. So, what we're building is an open data network. And we've kind of started to coalesce around this idea of a single source of truth and think about blockchains as single source of truth systems. And actually, thanks to incentive structures, blockchains are highly effective single source of truth systems and highly effective knowledge production systems. So when we think about single source of truth, we try to think about it in the way that it's always been defined in enterprise. And that is, say if any one of us are working with an enterprise or a consumer, we're known in that enterprise to one department as, say, a customer, and a different person in their CRM, and a different person to sales, and so on. And enterprise service buses help us to try to create a single source of truth about who that customer is. That's what we believe blockchains can help us do around rights. So, using the Ethereum ecosystem and Web3 infrastructure, we can power a new paradigm for content on the web, a single source of truth for content rights built on top of an open, inclusive data network, which we call Meta. Now, when we were coming up with this, we ran into a few problems. And the first is, if we want to build a single source of truth, we have to define truth. And truth is pretty subjective in the music industry because data changes all the time, and no one actually really knows if anyone is right. Who was on that song? I wasn't in the studio. How do I know? And so that creates a problem, and what we've tried to do is kind of a proxy for truth, and what we've kind of moved to is authority. So authority requires really robust identity structure, which kind of led us to building out this thing we call Meta ID. So you'll see here on the left that we have this thing called Meta ID, and Meta is basically an open decentralized data network that can be used to build decentralized databases based on Meta IDs, where participants are incentivized to provide trustless services to the network such that they can be automatically penalized by providing proof to a smart contract if the service hasn't been provided. If any of you were in the Swarm talk earlier on, or the one earlier in the week, you'd have heard Victor talking about swap, swindle, and a service layer infrastructure, and that's exactly what we're implementing here. So, with the Meta ID, the provider can convert their database into Meta objects and push them into the network as Meta streams. Then anyone can provide generic indexing services, so that's what the validators are doing here, and they basically enter into a service contract with a smart contract, and they provide service to the network, and using Merkle proofs, a node can just check that the actual information they provide as a meta stream is included in that index. Therefore, with our GraphQL API, we can basically query that graph of objects and serve it up to a dApp. Now, the interactions between contributors to the media graph DB, sorry, moving ahead a bit quick. In respect to music and media rights information, we can use the Meta network to implement a decentralized database which has a defined schema and is maintained by validators who are rewarded with tokens to secure the integrity of this specific database. The interactions between contributors to the, what we call media graph, DB here, which is basically participants who insert or update data into this database, and validators is governed by a swap, swear, swindle game, as mentioned in the Swarm talk earlier. The validators put up a stake which can be claimed or burnt if they failed to perform their duties, much like proof of stake. Now, what that allows us to do is build out this object, which we call smart content. Using Meta's media graph, we basically create a new index, which is called smart content, and the validators work to basically make sure that everyone conforms to that schema. And it extends the media graph schema to include assets, licenses, metadata, and anything else required to facilitate a commercial transaction. So you can see here we have our graph, and basically this is a swarm manifest, and it has a kind of a content address link that we can just find it, and it returns the rights information, the type of right, the percentage, the actual owner, which is a meta ID, and you'll see that we have these checks here, and checks basically just assure us that the person who actually owns this thing has signed it, or some delegate thereof. And that's really what the indexes or validators here are working to maintain, to make sure that this thing is adhered to. So this structure facilitates trustless kick-through licensing using smart contracts and service guarantees, using swear and swindle contracts where we get usage analytics and automated real-time payments for free. So what are we working on at the moment? A few things. So if you'd heard before, the Jack team has been contributing quite heavily to Swarm. And we started off by working on PSS, started earlier in the year. PSS being a routing protocol, which again is being spoken about just after this talk in the breakout hall. And PSS is a routing protocol, so meta nodes can communicate to each other and broadcast updates across the meta network. We also worked on a network simulation framework, which allows you to view the nodes that are in a swarm. And then we've also begun work on POT. And POT is basically the core infrastructure or technology that will be behind Swarm databases or SwarmDB. And we'll be working on that alongside a few of the other projects who are engaged with the Swarm team over the coming months. We've also been working on fully decentralized applications. What you're seeing here is an application that we were calling Jack, but we're deciding not. It's really called the Smart Content dApp. It's basically a dApp that allows you to build smart content and manage it. So the theory would be you enter into the network with your Meta ID, and you're able to load up any of the assets you actually have already built in. And then you can customize them, add licenses, add assets, so on, and push them into the Jack network. And it uses pretty much many of the components we've already discussed: smart content indexing, media graph index, Meta, Swarm, ENS, and Ethereum. So it's kind of trying to use the entire stack. So upcoming releases. First thing is the Meta white paper. We've been working on it for a while now. Some people may have already seen a first draft already. That really defines the structure that we're talking about here in terms of the service level agreements between nodes, which is quite powerful because it would allow things like licensing, where you just enter into a contract with the license and can provide all kinds of services, including the actual storage, serving up the streaming of the assets. Again, you saw the live peer people talking about that as well. And this kind of framework really, I think, will drive out all of the next generation of dApp development. The second part is the Meta ID dApp, and the Meta ID really allows you to create a public address and then connect all of these other authorized providers to it. So you can imagine signing up as an artist with a Meta ID and then being able to connect any of the other trusted providers, like your label or your publisher or your Instagram, anything where you like to dock your identity. And then the Meta testnet, which will allow you to start building these decentralized databases. We plan to push that in early 18, so you'll actually be able to try this stuff out. And final hat tip, so obviously I'm the CEO, I'm not the one building all this stuff, so I just wanted to let you know the people who you can speak to if you're interested in learning a bit more. Fred and Victor, obviously my co-founders. Fred's lead application engineer on Jack. Victor, obviously the architect working on Jack and Meta. Lewis Marshall, who's heading up Meta. He's the best person to speak to about all the stuff I just described. And Oren as well, who's also working on Meta. Then we have Lewis, who obviously is the developer working on PSS, and Luke, who's heading up Meta ID. So again, if you do have any questions and you do want to reach out to us guys, please do just go and reach out to them. And you can find us on, we do have a GitHub, github.com/meta-network. There we have most of these things defined conceptually. We have documents. We also have the Meta ID framework, the first version of that, which is open source. We plan to open source more things over the coming months, so please do check it out. We obviously are on Gitter, so again, just Gitter with the same thing, /lobby. And then if you do want to join us on Slack and talk about things that may be less technical, community.meta-network.io, and you can just jump into Slack there and speak with any of the guys. So yeah, that's the end of my presentation, and thank you very much.
Can I work here?
Let's get it. Yeah, they're pulling it up. Up next, we have Suryo Lerner with the blockchain virus. Can a blockchain pay to replicate?
Okay, my name is Sergio Demian Lerner, and I'm a Ethereum fan and part of the Ethereum community since its beginning, when I did the first security audits of the Ethereum code and design. And currently, I work for a company called Airscale Labs, which is developing an Ethereum-compatible sidechain to Bitcoin. But today's talk is about a research I did a couple of years ago that applies both to Ethereum and to Airscale and to any other blockchain platform. So the talk's name is the blockchain virus. Can a blockchain pay to replicate? Can a blockchain itself pay for all the resources it needs to survive, like an organism? Or it could have been called how to reward full nodes. Or it could have been called how to create a reward-based peer-to-peer file sharing system controlled entirely by smart contracts, by no additional blockchain, okay? So first of all, I'm gonna talk a little bit about decentralization, because we wouldn't be here if not because we appreciate decentralization. And any attempt to build a cryptocurrency or smart contract platform in the past that was centralized just failed. Okay, so this is what we must stand. This is what we must try to keep. So why is decentralization so important? Well, it brings back the power to the people. So this means a lot of things like people being able to audit their payments, disintermediation, having open access, no central control, no monopolies, no central point of failure, and of course, censorship resistance and corruption resistance. These are very, very important properties of our networks. So how do we promote decentralization? Well, first we have to identify, measure it, and then we can see how can we improve it. So one of the ways is increasing the number of independent implementation developers, full nodes, okay? And another way is by reducing the cost of running a full node. Because as the network scales, the cost of running a full node increases. So if I have to depend on a third party to know about my transactions, then the network is going to be centralized. And last, the actual full node topology is very important. If I take a node out and then the networks disrupt or disconnect, then of course this is not a good decentralized network. But we can see that in all kind of ways that we can improve decentralization, it's very, very important to have full nodes. We cannot live without full nodes and have decentralization. So what is a full node anyway? Okay, a full node does a lot of services to the network. It broadcasts blocks, transactions. It also hides the node's IPs, so we don't give an attacker the possibility to gather all information about the network and do partition attacks or denial of service attacks. Also, a node provides filtering services for light clients. And of course, the most important function, it has a copy of the state and the blockchain to serve to new nodes that want to bootstrap and sync with the network. But what are the incentives to run a full node currently? There are none, okay? So currently it's quite cheap, so we do it, but in the future we don't know. So anything we can do to reward full nodes will foster decentralization. So how can we do this? Well, there are very simple ways, but most of them do not work. For instance, we can create peer-to-peer paid services, like creating a micro channel from one node to a peer. Then I can easily, or a probabilistic payment, which also works. And then I can just ask for a block. And then you give it a block, I make you a very small micropayment. Well, the problem with this setup is, of course, that we can have proxy nodes. And proxy nodes can, charge a little more and just forward the request to another node. And so they just are there to, they don't contribute to decentralization. It just make the network be more expensive. Some other cryptocurrencies, some other networks rely on something called masternode. Of course, this masternode regularly ping nodes so they can vote so which nodes have to be rewarded. This, of course, has a lot of problems with centralization. These nodes are centralized, and also these nodes gather a lot of information about the IPs of the nodes, which is something we want to avoid. So I will present a third way of doing this. And the interesting thing is that this is a communication between smart contracts and full nodes without any other user or external system intervention. So basically, there is a smart contract that will say something like this. Give me a proof of work that proves with high probability that you store in your own hard disk a copy of the blockchain, okay? Or that you are so irrational that you are willing to buy a lot of hardware just to fake this proof, but you will spend more money than just buying the hard disk to store the file, okay? And I will tell you if nobody else finds that you have cheated. So if the full node A submits a proof in transaction data, then another full node can come and say, no, this proof is fake, and the smart contract can evaluate this proof. This proof must be able to be evaluated with very low amount of gas, and can keep a predeposit, A's predeposit, and reward B for providing that useful information. So to summarize, we want a node to be able to prove to all remaining nodes in the network that is storing the blockchain. Okay, so the benefits are obvious. We can detect proxy nodes. We won't pay proxy nodes. And we don't require any special change to the network for the nodes that do not want to participate. And maybe the drawback is that we are not actually proving we are serving the blockchain. We are proving we have a copy of the blockchain. But since we have a copy of the blockchain, we are in sync with the network, almost sure we are serving it, and the cost of serving it will be small. So to manage to do it, we need some cryptographic protocols, okay? So these are the previous attempts to do these kind of things. So we have provable data possession, which allows you a verifier to send some data to a server and then challenge the server to see if this data is still there. Also, we have proof of retrievability, where the same verifier can also have certain assurance that it will be able to recover this information in the future. These two are called proof of storage. So I will present a protocol, a very simple protocol, which is called proof of unique blockchain storage, that it's a proof of storage scheme, but also allows you to ensure that the other party, the server, has an actual copy of this file, okay? So this means that this file will be related to some identity, okay? So the same file cannot be related to two identities. So it is interesting that this year, Filecoin presented us very similar proof that they call proof of replication, that I also published a couple of years ago, and it's kind of the same idea, but it's worse. And I will tell you later why it has many problems. So in a nutshell, we take the file we want to prove possession, and we will encode it together with an identity. And this identity will be generally your node address, your Ethereum address or RSK address. So what we need is that the coding is fast, but it should only be fast enough, for not to interfere with your network operations. On the contrary, appending and updating will be a much slower operation. But again, not slow enough to interfere with operations. The property is that when you encode a file and you encode a second file, there is nothing to share in these encodings. So the server will engage in a challenge response protocol with a verifier, and he will use the encoded data, not the decoded data, but just the encoded data. And it must be irrational from the economic point of view to do anything else, like relay to another party or like having a supercomputer or whatever. So this is how the peer-to-peer protocol goes without smart contracts. So there is a honest verifier say, give me the hash of n pseudo-randomly selected blocks of the file and that have been encoded with your node address. And please do it in less than 1 second. So the honest prover has the information, just put the information to memory and hash it, and it works. Now, if there is a malicious prover, he can think of two things, okay? First, he can think, okay, I'm going to relay this same query, the same challenge to another party, but the problem is that the response he will receive is related to another identity. So he's not going to get paid. He's just going to be paying another party. If he wants to redo this encoding, the problem is that it takes a lot more than 1 second, okay? So in a sense, he cannot fake a proof. So to create this asymmetry, we need something I call practical asymmetric time encoders, or PATs. So we have a program, which is an encoder. We have another program, which is a decoder for a certain Turing machine. And we define the steps this program performs as the number of steps it requires to run for a random input until it halts. And we will ask that this steps function is mostly uniform. So we said that we have two programs, and we said that decoding, if I encode an input and I decode it, I get the same input. So we define the asymmetry ratio as the number of steps it takes to decode divided by the number of steps it takes to encode. So the desired properties of course, the program must be small, and if there is any other PATI that encodes the same mapping, then this function, this encoding must be relatively equally efficient, okay? And to guarantee this, we need to rely on some complexity assumptions or number theoretic assumptions to make sure that the encoding that we pick is one of the fastest encoding possible for that mapping. Also, we want, as I said, that decoding and encoding speeds will be practical for our application, and we want the highest possible asymmetry ratio, because that is going to protect us from the attacker trying to encode on the fly. Well, there is a function that has these properties. It's called the Pauling-Hellman cipher, private key cipher. It's a very, very old, one of the first number theoretic encryption systems. It works like this. Well, in this case, it's the opposite. Decryption would be like encoding. But so to decode a value, we just raise it to the third power modulo big prime and bit prime. And to encode it, we will raise it to a value u, which has approximately n bits, which is the inverse of 3 modulus p minus 1. So we get this encoding decoding property. So using the standard square and multiply algorithm, encoding would take 1.5 times n multiplications, while decoding takes only 3 multiplications. So the asymmetry ratio here is n divided by 2. Okay, so we can make this asymmetry ratio as large as we want just by taking a prime which is larger. So what are the practical parameters that we can choose that serve this purpose? Okay, I tested it in my laptop with a libgmp. So for n equals 2048, this is a little bit technical, but please follow me. Exponentiation takes 2.8 milliseconds, while 3 multiplication takes only 3.6 microseconds. So the theoretical asymmetry ratio is approximately 1,000. What I measure is approximately 7,077. So now think about the Bitcoin blockchain. Okay, so we get 1 megabyte block every 10 minutes. And it takes only 11 seconds to encode it. So it works perfectly for Bitcoin, and it works also perfectly for RSK and for Ethereum. And decoding is really fast. You get 71 megabytes per second. So that is not going to interfere with your node operations. If you want to get a higher asymmetry ratio, you can take n equal 20K, and you still are in the bounds that you can still use for encoding your blockchain. So this is the one-time blockchain encoding step. You take your blockchain or your file, and you split it in n-bit chunks, and then you scramble each one with your node address. And this scrambling can be very simple, can be just XORing with a full domain hash of the node address, and then you encode it with your slow function. So this is what a typical proof of storage looks like. You have some kind of memory bound problem because you want to prove you have a lot of data, and you transform it into a disk I/O problem like this. You take a seed, the verifier will send you a seed, and from that seed you derive a number of positions in the file, and then you will just access those positions and build a hash, okay? Well, the problem with all these constructions is that they depend on this technology. So if I use SSD, then the parameters are completely different if I use a hard disk. And also, these characteristics, properties, change all over time. So this is what we really do. We first do the step of encoding and creating this asymmetry. And then we receive from the verifier, in this case is the POOPS contract, the proof of unique blockchain storage contract, we receive a C0. With this C0, we will take some parts, we will derive some indexes, some parts of the blockchain or the file, and we will bring all these into RAM. Okay, so we are independent of the technology, the disk access technology. And this is the challenge response preparation phase. Now, we receive from the smart contract, like 20 seconds later, a second seed. Okay, seed 1. And, well, from seed 1, we will derive these indexes of RAM, where we will take these small pieces, small blocks, and hash them. Okay, well, we have transformed this memory bound problem into a CPU bound problem. Well, there is some important problem here that we cannot do this from a smart contract, is that the block interval can be about 10 seconds, 20 seconds. So the number k, the number of pieces we have to hash to prevent an attacker doing this encoding on the fly will be very, very high, okay, like in the order of 20,000 or maybe more. So the proof that we get is very large, and the smart contract won't be able to, you know, with the gas limits to evaluate if it is correct or incorrect. So we changed the last part, and we transformed a CPU-bound problem into a memory bus I/O problem. And this has been done. This has been done in Permacoin, for instance. The same procedure. So instead of taking a large number of blocks to hash, we take only 40, but we request that the hash that we obtain has proof of work. Okay, so we will try many times, like deriving new seeds from the seed 1 and anons. You know, try a lot of times, maybe 20 seconds or 10 seconds, until we get one that has this property of the proof of work. So this is how the whole protocol works, and it's very simple. So in the step 0, we have this one-time encoding, but we also have that full nodes will register with this POOPS smart contract. And this can be, they don't have to rebuild their IP, they just have to register RSK or Ethereum address to be paid. Also, they will do some pre-deposit because they are going to be penalized if they present an invalid proof. So in step 1, the POOPS contract will derive the seed 0 from the block hash and will give the nodes enough time to bring all these pieces or a big piece into RAM. So in step 3, the POOPS contract will derive a seed 1. And now the competition begins that it's not a competition, it's cooperation actually. But the full nodes will try to get this proof of work. We'll try to get from all proof candidates, we try to find one that matches, that has a whose hash is lower than the proof of work target. So they will submit these proofs to the blockchain in normal transaction. There will be plenty of time, like six blocks ahead to prevent censorship so that they can do that. And in step 6, there is a deadline for this, and then an external challenge phase begins. In this phase, full nodes will try to see if the other nodes are cheating. So they will pick the nonce and the hash that has been commit from other full nodes, and will reevaluate those proofs. But since there are only 40 elements, then it takes about 100 milliseconds. So they can just evaluate every other full node's commitment. If one of them finds that someone has cheated, then it just sends a fraud proof to the blockchain, to the proof smart contract, which is just the full expansion of this proof, which will show if the original commitment was correct or incorrect. So in step 9, there is a deadline for proof submission, for fraud proof submission, and then the rewards have been paid. Of course, they are only going to be paid to the nodes that are behaved honestly. So because the reward is going to be shared, full nodes are also incentivized to detect cheaters. Now, what's the difference? I said before that this protocol can be used to prove any file, not just the blockchain. The blockchain is the easiest one because the node already has a copy of the blockchain, maybe, so it can more easily evaluate things. But it can be used to any file to create, a file sharing system that you can reward node just to hold the data for you. And multiple copies. You can just create a contract that creates 100 copies of the same information. But there are some difference between the Filecoin's proof of replication and proof of unique file storage. Proof of replication depends on the success time. So it's difficult to tune for all kinds of disks. And it gives you typical asymmetries of about 10 to 100. So it's very easy that technology changes and then an attacker is able to fake proofs. On the contrary, proof of unique file storage does not depend on access time and has typical asymmetries between 1,000 and 10,000. And also, you can combine them, so you get 10 times more. You can combine 10,000 of asymmetry ratio of proof of unique file storage and combine them with 10 times more for proof of replication. Well, the summary is that, well, decentralization is very, very important in these networks. And increasing or setting a full node reward for the first time, we can incentivize the creation of new full nodes and keep the number of full nodes, even if we request them to store 10 times more information. And this proof of unique file storage and proof of unique blockchain storage allows you to prove that you have this unique copy of the file of the blockchain. And the important thing is this can be done right from a smart contract with almost no gas consumption. And also the proofs are very short. It's just a hash and a nonce. Okay, so this could be implemented in Ethereum or in RSK tomorrow. Well, we are working on implementation, and so when we open source, you will be able to play with it. So thank you very much, and the organizers.
All right. Up next, we have Andy Millennius with DAI Stablecoin. Give him a hand.
Hello, everyone. I'm here to talk about MakerDAO, one of the oldest and most ambitious projects in all of Ethereum that seeks to create a stablecoin. For those of you who don't know, a stablecoin is a cryptocurrency that is stable with respect to fiat currencies, making it a more useful form of digital money. So what is Maker? At its core, Maker is comprised of two tokens. The first is called DAI. This is the stable coin. It is an asset-backed hard currency. This means that every DAI coin is backed by some kind of valuable asset. And this is because DAI is a permissionless credit system. And all DAI are issued when users lock up their valuable assets in this permissionless credit system and issue DAI against them. The stability of DAI is maintained by a system of dynamic autonomous interest rates that automatically react to emerging market conditions and change the fees and incentives associated with using this permissionless credit system. The second token is called MKR. It is the administrative token of the system, and its holders comprise a decentralized regulatory body who use token governance to decide what type of assets are truly valuable and can be used as collateral to back the DAI stablecoin. In exchange for their services, MKR is used as the fuel for the credit system. And when people repay DAI and reclaim their collateral from the system, they must include some MKR as a fee, which is consumed by the system. So, what have we been up to over the last year? In a word, refinement. This last year has been all about removing complexity, adding simplicity, paring down the code, making it easier to understand. This is not easy stuff. A good day at Maker last year, a good day often involved putting one line of code on trial and scrutinizing it and thinking about it, and at the end of the day, removing it. We have used the Unix design philosophy to great effect in the MakerDAO system. Now, I talked about this a lot yesterday, so I'm going to sum it up simply today and say the Unix design philosophy encourages programmers to write contracts that do one thing and do it well, and to write contracts that work together. What I'm talking about is a modular approach to system design, focusing on one component, making sure it's right, and then composing these into higher order systems. This is not a new idea. This is a decades-old idea, and we have leveraged it to great effect in the MakerDAO code. We have also sponsored the creation of a ton of interesting developer tools and repeatable smart contracts. All the stuff I talked about yesterday, we pretty much exclusively built in the pursuit of our goals for MakerDAO. And so all of that cool stuff is just one cool way that Maker has contributed to the broader development ecosystem. And it's something that we're very proud to do here in Ethereum. Something else that we're very proud of, achievement that we're very proud of, is the creation of the Purple Paper. The Purple Paper is our Haskell reference implementation of the DAI stablecoin system. And it has been invaluable in the design of DAI. And the reason it has been invaluable are three. The first is comparison. It is well understood in computer science that creating multiple freestanding implementations of a system is a great way to verify your assumptions and see what kind of behaviors translate between one and the other. In fact, the Ethereum community has leveraged this fact to great effect in the diverse client ecosystem that we all enjoy, and in the creation of multiple implementations of the Casper algorithm. Similar sort of thinking there. We did this in Haskell, and it was very, very valuable. The second reason is for verification. Haskell has a very advanced type system, especially when compared to Solidity. We can achieve more expressiveness, and we can specify the behaviors a lot more rigorously using Haskell than we were able to achieve with Solidity. And it has helped us to think more clearly about the design of the DAI stablecoin system. And the third reason is simulation. When you have, when you design something like this in a separate programming language, you can actually run it. What you're looking at here is code, of course. So the Purple Paper is actually a model of the DAI stablecoin system, and we can use it on the command line to simulate the system and test our economic hypotheses. It will help with the administration of Maker over the long term. So all of this stuff, this refinement, this high standard of quality, this investment in our tooling, the Purple Paper, all of it over the last year, it's been culminating. It's been leading up to something, leading up to me standing on this stage right now. And it is my great pleasure to announce to you that the first release of DAI is coming in December of this year. so long. We've been working towards this for so long. I'm so excited. I'm so excited I might faint. I'm so excited I may explode into 10,000 pieces of confetti on this stage right now. Now I say this is the first die release because this is the first major step on the road to formal verification and all of the important die stability features that we need. But make no mistake, this is a major step. The landscape of Ethereum, the landscape of dApps is going to be changed forever when we have consumer-grade stability. Everybody knows that. And we have been working towards this moment for years, and we're ready. We finished our audit just 2 weeks ago. We are currently responding to feedback, and we are getting ready to launch this thing. Now I'm going to go into some detail about what is coming in this release. Let's dive in and talk about the credit system mechanics. This will be especially useful if you're not as familiar with the DAI stablecoin system. So I spoke before about how users lock up collateral assets and issue DAI against them. This is done in what's called a collateralized debt position, a CDP. And users they create CDPs, issue DAI, and use it for whatever, and then later they repay that DAI plus a fee and reclaim their collateral. But as you can see in the diagram, it looks like there's more value in terms of collateral than there is in terms of DAI. Why is that? It's because the system enforces it. And the reason that it enforces it is because the value of the asset, the collateral, fluctuates. And it always needs to be backing the DAI because DAI is an asset-backed hard currency. So because the collateral value can fluctuate, the DAI system needs to protect itself. Now, if the value of the collateral asset fluctuates up, if it appreciates in value, that's fine for DAI, doesn't matter. But if it fluctuates down and it loses value, DAI needs to take steps to protect the integrity of the entire system. And what it does is it liquidates the CDP. It reclaims the collateral and it sells it off for DAI to reclaim the DAI that it needs to get and make sure that all the books are balanced. You can think about it, you can analogize it to a margin call where the CDP owner made a bet, here they were wrong, and they paid the price. So what type of collateral is going to be used in this first release of DAI? It's called pooled ETH. And it allows us to back the system with ETH and protect the system in the event of extreme market volatility. In the next release of DAI and in future releases, we will use the MKR token to protect the system in the event of extreme market volatility, downward volatility. But in this system, because it's simpler to do so, and because we are still working on that aspect of the system, we use pooled ETH, PETH. So let's go into a little bit how it works. We call this a bailout mechanism. Let's go into how this mechanism works. At the high level, PETH is very, very simple. You just put your ETH into a contract, and you get PETH out. And PETH can be used to reclaim your ETH. So if there's 100 ETH and 100 PETH, and you put any ETH into the system, you will get 1 PETH, maintaining the ratio between PETH and ETH. But that ratio is not static. It is dynamic. And the reason it is dynamic is because PETH protects the system with this bailout mechanism. In exchange for that service, half of the fee from the CDP is used to buy PETH and burn it, destroy it. So if you think about it, if we're buying PETH and destroying it, taking that CDP fee and destroying it, that means that the remaining PETH has greater claim power on the ETH. Here you can see it can claim 1.5 ETH, where before I was saying it claimed 1 ETH. That ratio is increasing, and it's causing PETH to appreciate in value. This is what happens when the system is experiencing normal levels of ETH volatility. But what if the dreaded black swan event happens? In a black swan event, the price of ETH rapidly loses value, faster than the DAI stablecoin system can liquidate positions. And what we wind up with is an insolvent CDP, an underwater CDP. This means that the totality of the collateral that has been issued against this DAI is lower than the value of the DAI itself. Something needs to be done. We need to collect this DAI somehow. And the way that it's done is by minting PETH. So here, this red area on the diagram would be minted PETH, and it's minted and sold for DAI in order to keep the system solvent. So we're accessing the value of the pool of ETH in order to keep the entire system solvent and balance the books. But, as you can imagine, minting PETH means that the claim power is diminished. Here we can see now one PETH claims 0.66 ETH, causing the value to depreciate. This is why PETH in times of normal volatility should appreciate and only falls in value in the event of these snap moments of extreme volatility. The next feature is the governance fee. As I said, half of the fee is given to PETH holders. The other half is given to MKR as a payment for their service administering the system and choosing the important security parameters that keep the system safe. This is paid in MKR, as I said. It's denominated in DAI. And here, we will have the first main use case for this vision that we've all kind of been thinking about when it comes to tokens, this vision of decentralized exchange. Whenever we think about tokens, we often think about the user buying them and not even realizing that they're buying them behind the scenes automatically without thinking about it, without even knowing about it. We have developed this technology for this use case. So users aren't going to have to think about MKR, but they're going to automatically buy it in a decentralized exchange like Oasis or EtherDelta or 0x automatically and use it to close their CDPs. This MKR will be burnt, consumed by the system. The last feature is called global settlement. This is how we wind down the system gracefully, and it will allow us to upgrade. Like I said, it's going to be graceful. This is an orderly process. When the system is globally settled by the MKR holders, a few things happen in order. The first is that DAI becomes a claim on ETH, on the ETH collateral, at a fixed price. So it is as if your DAI, which is an actively managed stablecoin, suddenly became ETH. Just like that, at a fixed price. Next, CDP holders will be able to free their excess PETH. So if I put $100 worth of PETH into a CDP, and I issued $80 worth of DAI against it, and then the system was globally settled, I would get my $20 worth of PETH back, and whoever I gave that $80 worth of DAI to would get the other $80 worth of ETH. Simple, orderly. And then last, the PETH holders can exit to ETH at whatever rate exists for PETH at that time, whatever claim power it has. There are only 3 conditions upon which the system will be globally settled. The first is in cases of bugs. This is a safety precaution. You can never be too sure until the system has been formally proven. The second is extreme events of market irrationality. We're all used to this in cryptocurrencies. It's something that we are quite certain won't be happening in DAI, both of these things, bugs and market irrationality, but it's something that we're prepared to handle nonetheless. And by market irrationality, I mean something like an unstoppable amount of demand for DAI that threatens its very stability. And then the third case is in terms of upgrade, or in cases of upgrade. Now this is definitely going to happen because, as I said, we have another release of DAI coming, which is going to have more important stability features. And this will be an orderly way to go from the old system to the next system. So, what's coming next? A lot of exciting things. We're going to be working a lot on exchange integrations. This means that you're going to get DAI trading pairs. DAI is going to be a great base pair to trade against. And we hope to get our CDP system integrated into exchanges so that you get safer borrowing with much lower rates. Margin trading at 1% sounds awesome. The last feature is, of course, the last aspect we're going to be working on is, of course, the important DAI stability features. I mentioned a few here. There's a few more that I can't get into, but we're going to be heads down over the next quarter, working really, really hard to get the next release of DAI out there, which is going to be even better and even closer to ready to the final formally verified product. We are so excited that we've been working for so long on DAI, and we are so excited to deliver a working dApp to you. This is something that we're really, really proud to put out there. And I think that it's going to, like I said, completely change the landscape of Ethereum, getting consumer-grade stability. If you're interested in learning more, please visit makerdao.com. There's a lot of information there. You can join our chat at chat.makerdao.com. Thank you very much.
All right, thank you, Andy. We're going to have a 30-minute break, but a couple quick announcements. Number one, you only have 1 hour left to buy T-shirts, so go down there and get them. T-shirts close at 4 p.m. Also, the conference will be ending at, I believe, 5 p.m. So go ahead and get your T-shirts before they close out, and we'll see you back in half an hour.
vehicle. Prior to our car lease model, we developed a block.
talking about the thing. Well, about the thing. Well.
Good afternoon. Please take your seats for the last session. Now we have Designing IoT Frameworks with Ethereum with John and Lex. Thank you very much.
Good afternoon, everyone. Just waiting for the slides to come up. My name is John Garretts. I'm co-founder and CEO of Oaken Innovations, formerly Project Oaken. And I just want to start off by saying how excited, and I think I speak for the rest of our team when I say how excited we are to be here in Cancun at Devcon3 on this stage speaking to you. And when I say you, I mean the community that we've all been a part of for a number of years now. And we're really excited to tell you kind of the story of Oaken is what I'm going to start with over the last year. And then I'm going to hand it over to Lex. He's going to take you through a few of the technologies that we've been building out. And then we're going to wrap it up with a video. So again, my name is John Garretts. I've been in the space since about 2014, very early on in Ethereum years. One of the first projects I worked on, Airlock, was on Proof of Concept 3, so very, very early years. From there, I was able to secure a developer's grant, a dev grant from the Ethereum Foundation for ETH Embedded, which was essentially taking the Ethereum client and porting it to ARM-based resource-constrained devices. And that allowed me to start to build relationships in the community. And many of those relationships are now my co-founders with Oaken Innovations. This is our team. We have a fantastic team. I'm so proud of what we've been able to do in a very short amount of time. Many of you are familiar with Hudson Jameson, but we also have Lainey Fisher, James Johnson, Lex, and Daniel is the most recent addition. Shout out to Ethlance. Daniel was a recent hire. We went through the process of Ethlance, and so shout out to someone else in the community that we've used their tools and has worked out very well for us. So this is kind of the story of Oaken. About a year ago today, you know, the majority of us knew each other, but we hadn't really worked together. And so we got together about this time last year to enter into a couple hackathons. The kind of result of that was a judge's win with a Hack Ether camp. And then from there, we built on to a first place finish in the Dubai Virtual Blockchain GovHack. And first place was $100,000, all expenses paid trip to Dubai. And our project there was a proof of concept that we referred to as Tesla and Toll Booth. And what we were able to do is install an Ethereum client in a Tesla and install an Ethereum client in a mock toll booth to demonstrate the true machine-to-machine transactions with no human involvement. That gained us some traction from one of our partners initially, Toyota Research Institute, which we moved on to build out another proof of concept for peer-to-peer car sharing. And that was something that we debuted in May at Consensus 2017. And essentially what we're able to do is install an Ethereum client in a car, connect that to a fob, and through a series of escrow smart contracts, rent out or short-term lease that vehicle. And this is all these proof of concepts that I'm speaking to are functional proof of concepts. These are things that we have built out that are up and running, you know, not in a production environment, but up and running nonetheless. From there, we've been able to be involved in a number of other projects, I guess. MIT Media Lab, we're really working with Toyota Research Institute to start to facilitate some kind of an open blockchain mobility ecosystem. And so we've, you know, in the past we've invited other automotive manufacturers to come to the table, and we've been at least successful in starting that conversation. We're based out of Dallas, Texas, so we have a strong relationship with a lot of the universities in that area as well. We're involved in an open data initiative with the Texas Department of Transportation, or TXDOT, and we're also talking to a few toll road authorities, both in the US and abroad. We're a member of the Trusted IoT Alliance. We're very excited to be a part of this group. There's a lot of active members in the Trusted IoT Alliance. We're still kind of a small group, but growing fast. And ourselves, we've been able to contribute MQTT, which Lex will talk about in a little more detail shortly. And if you're out there and you're working on IoT and blockchain and you're interested in becoming a member, please go to trustediot.org, trusted-iot.org, and check it out, sign up, and we'd love to have you on board and kind of learn more about your technologies. So it's now my pleasure to introduce Lex Shuangliang. Lex is our CTO, and he has some prior experience. Lex and I met in Guelph, Ontario, Canada, which is close to my hometown. And you know, we kept in touch after that initial connection. Lex did some IoT internship work for Eris Industries, which is now Monax, and joined the team just prior to the Dubai event. So please give Lex a round of applause.
Thanks, John. So good afternoon, everybody. So I'm Shuang, or in Chinese, Liang Shuang. You can call me Lex. And I got my master's degree in computer science at Temple University in Philadelphia. So I'm glad to be here to introduce some of the technologies that we are working on recently. So yeah, the first one I want to introduce is the MQTT trusted, and the second one is the micro DAP. And also we have a hardware security model we are working actively with to build some secure hardware for the IoT platform. Yeah, MQTT trusted is a trusted version of my MQTT. So it's based on the MQTT library and the Ethereum library. MQTT is a very lightweight PubSub-based machine-to-machine communication protocol. It's very popular for IoT applications. And it's designed for very low bandwidth communication for some sensors or telemetry devices. And the feature we want to bring into this machine-to-machine communication is from Ethereum global, likely unlimited identity system, and also it's trusted without the centralized control. And we can use the built-in ECDSA algorithm to get the signature of the messages and embed that signature to send to the receiver. So here is the flow. From the sender side, it put the plain message, and the MQTT library will build some packet like this. It has a from and to field, which is based on the Ethereum address. And we put the timestamp as the proof of date to say to put some constraint of the operation of the message. Also the date load and the sequence number. And after that, we'll use either the private key of the Ethereum or hardware security model to send the message and put the signature into that message. And at the receiver side, it first can recover the address of the sender based on some Web3 library or Ethereum library, and it can check the permission of the sender from the smart contract. Also, we can do proof of provenance of the data or access control based on the identity of the sender. So there are some issues we want to solve on from this library. It's interoperability. There are some problems. The first one is signature can be messed up if the sender and the receiver use different libraries to send and recover the message. And the second issue is this part of the properties are not standard yet. So we want to probably standardize this machine-to-machine communication scheme. So it will be either for your fridge to talk with microwave or some talk with your car. So they are all compatible with each other. So because of these issues, we want to collaborate with the community, with the Trusted IoT Alliance to build some standard for the machine-to-machine communication, also build some semantic on top of the Ethereum blockchain and this protocol. So the next one we want to introduce is the micro DApp. So you can see from name, it's small version of the decentralized application. We use Raspberry Pi for our hardware platform, but we can also port our stack to other embedded system like BeagleBone and other embedded device. So, sorry. We use Ethereum Light Client for the smart contract and IPFS for the data storage and the MQTT library to support machine-to-machine communication. So this is an example of the architecture we are working on. From the top layer is the decentralized application for design for IoT use case. And we have 3 components. It's the first one is decentralized data storage API and the trusted machine-to-machine communication interface to the application and also the smart contract. So in the middle layer, we have IPFS, but you can actually plug in other decentralized storage libraries like the Swarm and the MQTT, the Ethereum blockchain. Actually, we are trying to build like to support other blockchain like Hyperledger, Quorum. And under the lowest layer is the hardware abstraction layer. We can support center data and hardware secure model as IoT wallet. And here is an example for the microdApp service to interact with the user using the mobile app or web app. So here, GBoss has access to the Ethereum blockchain and IPFS for data storage, but it's not like pure centralized infrastructure. We still need some like server to offload the computing task from the embedded device to the servers. Here we use MQTT broker on the server side. Also, we need some server to offload the Ethereum gateway and IPFS gateway to support the constrained device. So here is the real-world example we built with Toyota for the car sharing, decentralized car sharing application. So you can see it's not like a traditional server-based design paradigm. It's really like peer-to-peer design paradigm. All of the cars have our microdApp services running, and they can communicate with each other through the MQTT machine-to-machine communication and access to the smart contract. So we have the video to show the real app and the user experience later on. I'll go very quickly for the hardware secure model. We built this hardware secure model with some requirements we want to for the IoT and blockchain application. First one is we want tamper-proof to prevent the attacker like physically attack the device. And we want very secure key storage and revoke the key when we detect some attack intention. Also, we want it to be blockchain compatible, like we can send using the hardware secure model and using this signature compatible with Web3 library or other Ethereum libraries. So here is our current accomplishments for the hardware secure model. We can send offline transactions and we can send personalized transactions. Also, we have this Node.js library to access the functions in the hardware secure model. So there are still ongoing work we actively develop. Like here, we are developing the physical tamper detection with collaboration with some hardware companies, and we are building this secure key story based on the secure elements. Yeah. These all are like ongoing projects we are actively working on, and we are like community driven and like to talk with developers. If you have questions, you can go to this website and stay tuned. We may have more release like the MQTT to the community. Thank you.
Thank you, everyone. So, as Lex alluded to, we've been in as much work as Lex has done on our back-end systems. We've really been focused from the get-go on the front end and really making sure that there's a good user experience. In fact, some of this was born out of necessity for us to keep that user experience at a level that we're comfortable with. And so we're just going to play a quick video for you now. This was first launched at Money 2020 last week in conjunction with Toyota Research Institute, and kind of gives you our vision of the mobility future.
Hello from Oaken Innovations. We're excited to show you what we've been working on with Toyota Research Institute. Earlier this year, we debuted our proof of concept, blockchain-enabled peer-to-peer car lease application at Consensus in New York. This application allowed consumers to lease a vehicle from a car owner, using a smart contract on the Ethereum blockchain, file storage on IPFS, and a mobile application to lease and control access to the vehicle. Prior to our car lease model, we developed a blockchain-powered automated toll road system with connected cars. This project won us the top honors among the entire world at the UAE International Blockchain Hackathon. These applications allow for instantaneous remittance between the transacting parties. They do this without the need for payment processors by using logic coded to a smart contract. The hyper-secure blockchain-based IoT controls add a level of security not currently available on the consumer market, all while reducing or eliminating the need for server infrastructure. Oaken Innovations wants to give you a glimpse into the mobility future we envision. We use the blockchain for application logic and data storage, replacing traditional server infrastructure. Here we use the blockchain to store vehicle identity along with GPS. Now we add road and mapping data and allow trusted entities to update this decentralized data layer. Smart road sensors can also feed this database. This allows for a complete view of all vehicles and infrastructure with current construction and traffic conditions while allowing third-party applications to be built on top of this data. Let's amend that vehicle data for lease or ride-sharing services. This now allows consumer mobile apps for ride-sharing or leasing using this blockchain services layer. In a ride-share or lease transaction, things get very interesting. Using blockchain technology, instant value transfer and microtransactions are now possible. Within one smart contract transaction is instant remittance to several parties, including the vehicle owner and driver, insurance provider, toll road authority, and road tax entity. Why is this valuable? The automobile owner and driver receive guaranteed and instantaneous payment of funds. Microinsurance policies for each ride or lease transaction can be paid to an escrow contract, then remitted to the insurance provider once the ride is complete, with the balance of that escrow going to the rider or lessee. We can use an escrow contract for autonomous toll payments and even eliminate toll gates from the toll road infrastructure, as we can prove the location of the vehicle using GPS. We can even have smart toll road infrastructure where roads are only charged during peak hours. As consumer behavior moves away from purchasing fuel and favoring pay-per-ride mobility over vehicle ownership, road and infrastructure authorities will face a shortfall of tax revenue that currently funds the construction and maintenance of roads. Included in the mobility transaction is a usage-based tax to replace this lost revenue, even short trips where a fraction of a penny is needed for taxation. All of these parties receive the benefits of instantaneous remittance, all included in a single transaction user experience, all without the need for payment processing intermediaries. Let's go further. With this blockchain platform in an autonomous driving world, we get to go beyond rider mobility into other applications. Solar energy production is highest when the sun is shining the most. That's typically in the middle of the day. Energy demand typically spikes in the morning and then again in the evening, time that solar energy production is weakest. During low mobility demand times, automated vehicles can store solar energy during peak production times, then deliver that energy when and where it is needed. Also, since we have the automobiles equipped with 5G connectivity, we can provide a self-healing mesh network across large areas, as well as a partitioned consumer Wi-Fi service, all while the vehicles receive microtransaction reimbursements for sharing their internet connection. Thank you for your time, and we hope you enjoyed our version of the blockchain-powered vehicle future. For more information, please visit us at oakeninnovations.com and blockchain-mobility.org.
Thank you. The next session is Garrett MacDonald and Brendan Playford presenting the energy blockchain in 20 minutes. They're presenting it now, but it takes 20 minutes.
Hi everybody. My name is Garrett MacDonald, and this is Brendan Playford. And
Hi guys.
And we're here to tell you about the energy blockchain, give you an overview of that. So today we just would love to take the opportunity to talk to you about a couple different things. First of all, we kind of want to frame the situation of the state of energy markets today, and define the opportunity for a new energy paradigm, and point out how current public blockchain infrastructure is generally incompatible with the energy infrastructure today, and how we're building a new infrastructure that will enable that transition, and then give it an example of an application that'll run there. So energy infrastructure today was largely designed a long time ago, and a lot of regulation that applies to it today, which stifles the innovation, was put in place about 100 years ago and has been lobbied for to keep in place since then. So there's massive inefficiencies in the entire ecosystem and infrastructure, and the control and distribution of energy today is actually quite antiquated. So there's a lot of regulation that's preventing us from implementing a new system, so it's super important that we work with the current incumbents to integrate this system. Yeah.
Yeah, so I just want to quickly ask everyone in the room, how many of you here are kind of aware of how your energy, what process energy goes through to get to your home right now? Do you even know whether you're in a deregulated space or a regulated space? There are certain states in America. Hands up, really, if anyone fully understands the process through which their energy goes to get to them. So that's one guy over here, not many people here. So the infrastructure that we have right now is pretty antiquated, and it's set up for a sort of centralized, highly capitalized market system whereby you generally have monolithic generators on a network that transmit power directly to a consumer. In Europe, that's changed a little bit with deregulation, and certainly in the US markets where you've got California, New England, Texas deregulated, which gives the opportunity for more competition, a little bit more exposure for other players to come into the market and offer unique products. And really, you know, there's limited opportunities for new players to come in. There's limited opportunity for new technology to be embraced. For example, novel gasification. We obviously have a big rush for solar and wind right now, which is being very, very well financed. But also a lot of like small-scale projects.
Yeah, and today there's a bunch of huge inefficiencies, and basically it boils down to for every 100 energy units that are generated and intended to be used by a consumer, only 10 of those actually get to the endpoint. And when you apply this model to something like a data center, for instance, it's closer to 1%. So this is actually ridiculously low, and most of that happens because of inefficient power generation. So if we can localize the power generation and provide an infrastructure that enables that and enables the value to be transferred in that new ecosystem, then we can really increase the actual delivered energy flow.
Yeah, and I'm just going to add something to that really quickly as well. The International Energy Association by 2050 is planning on getting 57% of all renewables to kind of give global supply of energy. So 57% of the total energy produced will have to come from renewables. Now, an interesting point to note about that is when you look at renewables technology, a lot of it is decentralized distributed power, small-scale stuff which doesn't really have any links to a network right now. So if I've got solar panels on my house, yes, that's great. I might have a grid tie. I might benefit from a feed-in tariff. But there's a whole host of other tokenized sort of derivatives that you can take from that model which can unlock a huge amount of economic abundance from already distributed systems. In order to coalesce all of these things together, we can do that really well on blockchain. So I'm going to leave Garrett to talk a bit more, and then I'll come back to those points.
Yeah, so basically, to enable this new energy future, what we need to do is create a network where every single device that's able to consume or produce energy is connected as a node. And that node is an agent that's aware of all of the other nodes in its locality and can react dynamically according to the current market conditions, how much energy is being sold for, what time of day it is, whether there's an abundance of solar power that needs to be consumed to not flood the market or flood the power lines. And there's actually quite a difference between interacting in physical infrastructure like this and something like finance, where here, if you mess up some numbers, then you can actually cause fires and deaths. It's not just a simple rewrite. So it's actually very, very critical that the infrastructure is completely secure and that we do it very correctly.
Yeah, and I'm going to add something to the end of there as well, which is when you're looking at how these bits of hardware infrastructure get financed, it's obviously in the interest of the actual utility operator, so the actual generator on the network, to finance that and create a sustainable way of getting return for investors on those big capital projects. Again, going back to the fact that renewables are generally distributed systems, in order to bring about and unlock value and create more incentive for people to either crowdsource or pull together of resources or small groups of community investors into, I don't know, like a biogas or a wind project in Africa, giving a platform where people can come together to actually finance that, giving these distributed systems where at the moment you can take a renewable energy credit, for example, for a small solar installation on your house and participate in the ROC or the REC market, which for small independent people with solar panels on their house is not something they can do. You generally go through an agent, you generally bundle these RECs or ROCs up into one package and send them out to auction. So we're looking at creating like a frictionless way of moving value around this system, and that's moving value not just of energy, it's also ways in which smaller producers and smaller participants in the network can benefit from getting value from what they already have. And I think that's like that unlocking of value is really powerful here with what we're looking at. It's going to give people a much more frictionless experience and able to do more with what they've got.
Yeah, absolutely. So here's a little demo that one of our partner companies made, Grid Singularity, that just shows a simulation of a local energy grid where where each section of the network is able to dynamically react to the others, and it just shows an example of pricing, and if you turn off the power plant, how the houses in that network react. So you can see that when the power plant is turned off, that the houses will dynamically adjust their consumption and production loads and basically just react to that. So that way, in the event of an actual outage in a real power plant, the houses will be able to still consume power locally and produce it and interact with each other. And this is going to be a huge resiliency improvement for energy grids all over the world once this is implemented. So of course, the infrastructure today doesn't work very well for that, so we're building a new one, and it's called the Energy Web Blockchain. And we have our testnet live right now. Our netsets page is live, and we just open sourced it on the 1st of this month, and everything's accessible there. We can do 2,500 transactions a second right now because it's proof of authority. The authorities are energy companies that we currently trust to keep the lights on, so we figure that it's reasonable to trust them also to validate blocks correctly. And right now it's an open network, and it will always be an open network that anybody can use freely and run applications and transact value. Any Ethereum smart contract, of course, is completely compatible and can run on the Energy Web Foundation blockchain. And interchain communication is something that we're very much prioritizing, and we want to have that coming really soon. So for instance, projects like Polkadot will be very high on our list to implement, so that way we can interact with the Ethereum public blockchain as well.
And I think I just want to reflect on a way that I'm involved in this mix. The project that we're working on right now is called the Aurora Network, and what it is, it's an open source hardware project where through these mechanisms we're building, we can actually deploy hardware that's innovative and otherwise wouldn't find funding. So I've got a really good example, biomass gasification, particularly small-scale biomass gasification, classically is pretty much unheard of unless you're on a commercial scale. And when you look at the way in which, going back, can you just pop back a couple of slides, one more? One more. Yeah, to this whole household model here, when you're looking at, for example, solar, there's a supply-demand curve of which you've got, say, this massive abundance of solar energy during the day, currently not sufficiently deployed storage batteries to take that power offline. And our usage is generally out of whack with that. Like, we're all at work during the day. The majority of like actual power consumption isn't until the morning or the evening. You get this dull period. And we're all used to getting cheap electricity in some regions through the night. You get the economy saving between like 1 a.m. and 7 in the morning. That's because big power stations have to keep running. They don't just shut down. Shutting down costs a ton of money. So by implementing this system whereby you can take energy as and when it's needed from core parts and understand what equipment you can bring online and when. So for example, in a time of high demand, you have a bit of equipment that would otherwise cost more to run or more to like produce a unit of energy. That may come on in these times of high demand, and you may have a variable pricing model for that. So that energy can be used and acquired and sort of leveled across the network, but you effectively smooth. And this is like a smart grid effect. And a lot of these companies are kind of moving towards this more smart grid. And again, this vision of a more distributed power network. This beautifully supports that. And when you're actually looking at tokenizing, for example, the energy on the network, you need a high transaction throughput to do that. The rate and volume of which you're planning on scaling to make this be a very impactful global sort of infrastructure that allows this transfer of value and flow of markets globally, so you can take abundance in one area and maybe deploy that in an area where there may not be the infrastructure or the actual drive to develop in an African community, for example. So California is a great example. California, there is an abundance of walnut shells that are supplied by walnut manufacturing companies. So where do they go right now? Those walnut shells are dumped or burnt. There is no value being created by that byproduct. So take those walnut shells, put them through something like a gasifier on site, have a grid tie that back to the network, and actually use that energy in a way where you can either sell that directly to a consumer using your tokenized model and link that with more of the smart meters we're seeing. Like, there are these inductive smart meters where you clamp them onto your incoming feed of your house, and it will do a Fourier transform on your frequencies of your energy, and it will tell you, after about a month of learning, your fridge is using 60% of the power. Your toaster is using 0.1%, whatever that mix looks like. And if you analyze that data, you can actually start incentivizing good actors in the system. So I can make an assessment of what the usage in this house should be. If an actor is overusing that, they pay a fee. If an actor is underusing and coming below a threshold, they get paid that back. So you're not just incentivizing smarter energy distribution, you're incentivizing good behavior, and you're incentivizing better practice on the network whereby the participants contribute overall to a lower demand, and that's done in like a fluid and organic way.
And because everything is so static right now, for instance, in California, sometimes there are events where in the middle of the day, on a hot summer day, there's a bunch of abundance of solar power that the market just doesn't need. The rest of the resources are not flexible, so they're not able to ramp down production fast enough to actually utilize the solar energy. So the utility companies sometimes ask the solar producers to turn off their panels, so that way the abundance of electrons don't flood the network. And so this is obviously a huge waste and not effective utilization of our solar industry. So yeah, basically enabling all of the resources on the network to be a lot more flexible will enable a much higher utilization of all the electricity we're generating from renewables, especially the ones that vary.
Yeah, and I think this vision as well for the more IoT connected sort of state. So where you have these feedback mechanisms into a smart grid, where it understands exactly what to switch on and off when, is really kind of that utopian vision of a really efficient marketplace where you're, again, going back to allowing a nice flow of value. So when you unlock value in systems that isn't currently used, our vision is to then use some of that elsewhere in the world to make an actual impact. So take that station that's really abundant and producing revenue and using a portion of that to develop other infrastructure elsewhere, invest that in more kind of skunk works, new development, open source hardware, which does exist out there that currently isn't getting the attention because it's hard to monetize, hard to justify costs, and incumbents just would like to continue in the current paradigm.
Yeah, exactly. And so the ecosystem within energy applications that are seeking to use blockchain infrastructure in some magnitude is expanding super rapidly. This is a smattering of companies that are trying to accomplish this. Some of them we have agreements with already and we're working actively with. We've spoken with all of them. All of them have shown interest in using the InterWeb blockchain for the purposes simply because you can have a lot more transaction throughput and so on. And some of them have gone to the point of purchasing tokens in the InterWeb blockchain, which are used as gas, similar to ETH and Ether and Ethereum. So yeah, I just wanted to say thank you very much. It's a huge honor to be here. Thanks for having us. And yeah, we do have a couple more minutes left, so if there are any questions, we're happy to take those.
Thank you. Thanks, guys.
Yeah, thanks.
Did anyone have any questions? If you don't, that's fine. If you do.
There's one right there.
Yeah, go for it.
So in your presentation, there was a slide where you mentioned that energy demand fluctuates throughout the day, and that doesn't coincide with energy that's produced through means like solar. My question is, what role do technologies like in-house batteries, think Tesla Powerwall, have in addressing that specific problem?
Yeah, absolutely. So basically the idea is with the Tesla Powerwall is if you have an infrastructure that supports the leasing of batteries on a short time scale, like for instance over the course of a day, then if there's abundance of solar on one home, for instance, if we just go back to the simulation, if there's an abundance of power on this home because they have a lot of solar panels and only 2 batteries, and this one doesn't have that, but maybe he has more storage capacity, then basically you can lease out the battery and use that solar power throughout the day to power everything during the night when it's not there. So that way you're shaving the peak a lot. So batteries like that play a tremendous role in actually utilizing the solar power more effectively, even though you have an obvious decrease in efficiency when you store electrons in a battery. You lose some, but the gains over just utilizing the normal grid is tremendous.
Yeah, and I think something I'll add to that as well is not just to be too narrow in solar, is to also look at a lot of the other technologies that are out there. So in the UK, there is a system called the Triad Network, and what the Triad Network does, it is a bunch of distributed diesel gensets, very, very big, substantial ones tied to the grid in strategic locations around the UK. Between the hours of 6 and 7 p.m., they all switch on. They switch on, they provide a very expensive kind of surcharged power, which balances this load. So I think it's about thinking about how you can also bring on more novel technologies, like you can use recycled cooking oil that's been reprocessed in a diesel genset as a biomass fuel in a strategic location. The infrastructure for that costs a little bit more, but if you are able to switch it on at the right time of demand and only use it when demand is high, then that can help balance that load. So it's a combination of storing and finding dynamic load in the network that can instinctively switch on based on the load balancing that's kind of in the smart grid to bring that power on when it's needed. So you've got this nice blend of battery, which is going to take some time to kind of get affected on the network, and novel technologies there to boost it, but focusing on renewables for that.
Yeah, exactly.
Okay. There was a really interesting talk yesterday that treated this as an optimization problem. I guess I'm curious what the change in efficiency is between the optimized version and the normal market, if you know.
I can take that.
Sorry, in terms of like...
Yeah, thanks.
Yes.
If you could repeat yourself, I didn't quite hear between which market and...
There was a speaker from Berkeley the other day.
Yeah.
Who essentially had everyone sort of bid and schedule stuff. And I guess it sounds like it's sort of a real-time auction.
So I think what you're asking, are you asking between the future vision for a network like this and what we have currently, is it just an optimization exercise where value's coming from efficiency savings because we have a little bit more fluidity in the network? Is that what you're saying?
No, but I take back my question, I guess. Sorry.
Okay, sorry.
Anyone else?
Hey, here. Well, thank you for the talk. I had a quick question about distribution, because you talk about production and also storing at the local nodes.
Sure.
But isn't there an issue about distribution still being somewhat centralized and also in waterfall pattern, which would prevent peer-to-peer or sell energy to my neighbor kind of thing because there's no connection there?
Yeah, right now the distribution grid is definitely centralized, and the idea is to work with them and bring more and more distribution grid owners onto this network, and then eventually we'll be able to decentralize the ownership of that. Of course, that's what we all want. We want a completely decentralized system, but enabling the current incumbents in the market to start acting with these technologies and profiting more from these is the first step to getting them on board to a really, truly decentralized system. Yeah, you're completely right that it is still centralized in that there's generally one monopoly in a state like most of California or a state like Colorado, where one company often owns the entire distribution grid. Yeah, we hope that'll change over time.
Yeah. So isn't there a physical limitation by the fact that you can't actually even send energy from your home because there's no...
So it depends. I think what you're saying is, we've got deregulated markets and regulated markets which will allow generators access on or off the network, and that is split into, you've obviously got the generator, you've got the transmitter, which is your DNO or your local operator, which is your power lines, you've then got the utility on the end, which is your retail side of it. Now what you're saying is that bit in the middle, which is generally controlled in non-deregulated markets, in regulated markets, the likes of Colorado, that is something that if you want to supply directly to the end user, you can't. If you want to supply directly to the energy provider and they will pay you a pretty poor rate for that energy, then you can also do that, and it's then bundled up in their package. What I think this is going to do, it's going to increase competition in markets where there is already deregulation, like Europe, like the UK, like these particular states in California. And what it needs to be a community effort to influence and lobby as well through relationships like EnergyWeb are doing, like bringing together a consortium to all view this through the lens of, this is the future. These companies all want smart grids. They're struggling to understand how to do that. And if you can place their weaknesses with giving them sort of power in areas where they currently don't have it, where they have these deficiencies, where they need to top it up, it's all about working together and understanding where to start and then where to influence to move forward. But I think there'll be more power, at least from this, in the hands of the operators that are building infrastructure independently than what there currently is.
Thank you.
Hi, I just had a quick question about the proof of authority chain.
Sure.
How are users expected to pay gas costs? Where would they get Ether to pay for the gas costs?
Right now, users, in the test network, it's handed out for free, of course. In the full network, we're still figuring out the governance principles and stuff. We're not launching the main network. The Genesis block will be in the beginning of 2019. We're still in an exploratory phase, figuring out exactly the best mechanisms for that. But right now, the idea is you purchase it like you'd purchase Ether.
Okay, thanks.
Okay, gotcha. Great. All right, well, thanks, everybody. I really
thanks, guys.
It.
The next speaker is Robert from Mysterium, talking about protecting user privacy in the blockchain ecosystem.
Testing. Hello, everybody. All right. Nice to meet you. My name is Robert with Mysterium team. And I guess this Devcon has been a lot about privacy, and you have seen a lot technical talks about privacy. And this is ending, Devcon is ending. So I would love to leave you with some fundamental thoughts about what privacy means, what does it mean in our daily lives, what does it mean in our everyday use of blockchain and internet apps, and if it's even possible to protect it. So let's start off. What is privacy? What is anonymity? Are they different? Are they the same? And how do they apply on our everyday life? Privacy. Well, what does it mean to have privacy? When you engage in an activity, let's say an online activity, you log into your bank account, you log into your Facebook account, you talk to somebody, you go into the bathroom. When you engage into an activity, privacy means having control of who has access to that activity together with you, if anybody. When you're creating your private keys for the wallet, you don't want to give access to anybody unless, I don't know, it's your wife. But when you log into Facebook, you give Facebook the right to change things, but you trust Facebook to not change things beyond what you tell them to, like clicking on the like button. And if there is any entity, third-party entity, unauthorized entity, which is monitoring your actions, that means you've lost your privacy. And if that entity can monitor your actions and even change things like block you from going into Facebook, if you're in China, for example, well, that means you really lost your privacy. Anonymity, on the other hand, is a little bit different concept. Anonymity means you go out into the world and you want the world to see what you're doing. You just don't want the world to know who you are. Like we're sending ethers on blockchain, everybody can see those ethers being sent. Nobody knows who is the person sending them or who is the entity doing that. And both concepts are really important. Privacy is there for us to be calm, to calm down. And anonymity is there for the society. It's a catalyst of change. Without one, we would not have freedom of speech, or at least we would be very afraid to do so. So, on the fundamental level, anything that happens on the internet is basically communication, right? Entity A is talking to entity B, and they create a communication channel. And over the last couple of decades, this channel has been, well, I don't know how to say it, breached, to be the least. You can monitor what's happening and sometimes even interrupt the communication. Let's talk about the same example, Facebook app to Facebook server. When you're in certain countries, you just can't reach that server. Why? Because somebody can see that, that communication channel being opened up and they cut it right there. So the question is it possible to even protect this channel between those two entities? And those two entities can be anything. It could be a device talking to a server, app to app, app to server, server to server, anything. So is it possible to protect identities of these two? That would mean anonymity, and to protect the content of the communication happening between those two, that would mean privacy. And we believe it is, and that's what we set out as a mission for ourselves. To protect the identities and to protect the content so that no third-party, unauthorized third-party entity could take a look, see who is talking, and understand what they're talking about. So protecting privacy and anonymity. The question is, of course, how to achieve this. And we suggest to do it in a couple phases. As a phase one, we're going to be building a decentralized network of VPN nodes, which means basically that anybody can become a VPN node. Just download an open source app, run it on your computer, and that's it. Anybody can connect through you if they need that communication, and you'll be paid to serve this service. On top of it, we're going to add a couple layers. For example, a decentralized discovery mechanism, so it wouldn't have a single point of failure. An anonymous identity management, so that you would know, like if entity A is using those 3 nodes, they would know whom to pay. And of course, an anonymous payment mechanism, so that, again, it could not be tracked. In this case, entity A, if they want to talk to an entity B, let's say Facebook app to a server, they would connect to a first node, and let's imagine, I don't know, a Catalan situation, and let's think there's a bit of a crisis taking place right now, and if the communication would be blocked, so they would connect to a first node somewhere in the Catalan, then the connection would be encrypted, and the contents would be hidden, identity would be hidden. From this node, it would go to the next node, I don't know, here into Mexico, finally to the third node right next to Facebook headquarters, and then right unencrypted. In this place, all the way up to the third node, the traffic is encrypted, and after the third node has the keys as well as NTTA. They decrypt the traffic, and it goes to node B. It's an amazing technology. It can open up borders. It can go around, I forgot the word, basically, you cannot block content anymore because you cannot see what is taking place. But of course, there is a little bit of, like, the final stretch is still not fully protected, because you still have, like, for example, a third node can still become the node that's rogue and can contribute to the cost of tracking data and blocking data and man-in-the-middle attacks and all the other things happening. And between this node and the final destination, there could be an ISPs, which again act as malicious ones, and vice versa. So, is it possible to completely protect the channel between A and B so that it would not be possible to see who is talking and what they're talking about? And we believe it is, and that's what we're offering. Basically, after phase one, when we're building this infrastructure, when this is done, what we're going to do is we're going to open up a protocol, and any app developer who's wishing to protect their users talking to each other, to protect their servers talking to each other, protect their users talking to servers, will be able to do so by integrating this protocol. And at this stage, the messages going out from the first place would be encrypted here, shredded, sent through multiple nodes, recollected at the exit node, at the destination place, with private keys, which A and B have. They could be reassembled into a coherent message and consumed. A and B trust each other, so they have no problem of sharing this information. Everything from outside would look like lots of gibberish. Every node would have, for example, node 5 would just see node 4 as some node, and they would relay the message to B without ever knowing if B is another node or the final recipient. And the same way goes for the node 4. Node 4 would never know if A was just another node or a original sender. In this case, what we would have is we will have a private, privacy protected because of the communication content is not recognizable for any third party, not even a node, not us, not anybody. Anonymous, because identities would be protected because only them would know who is each other, and trustless because no node would ever be possible to take this information and make any meaning of it. So yeah, this will enable any app developer to integrate this private communication channel into their apps and making an unstoppable app. So that's it. I thank you, and let's work together. If there is any time left, maybe you want to ask some questions. I did forgot to tell, of course, that it's an open source platform. All the code is on GitHub already. So yeah.
Hello, I just had one quick question.
I don't see who's asking, but yeah.
Hi.
Oh, yeah.
So you split up the messages into the different nodes. Yeah. I think this is a dumb question, by the way, but you split the message up into the different nodes.
Yeah.
What happens if one node goes down and the message doesn't come together at the end?
Exactly. Of course, we don't have this working yet, so I can't really give you a definite answer. But what is possible to do is it's possible to break down into an overlapping messages, so that we've lost the graph, but so that the same part of the information flows through different nodes and then gets reassembled. Yes, of course, there's a certain amount of waste, but then you're secure.
Hi, I have a question. To my knowledge, I think it was the GCHQ launched up a whole set of like Tor nodes, for instance.
Okay.
And if they had sufficient Tor nodes, then they knew, okay, well, we're getting a message, we're sending it to one of our other nodes and one of our other nodes, and eventually they could de-anonymize Tor that way.
Mm-hmm.
If you incentivize them along the path, though, even if you do scramble it, aren't you afraid that that would actually just pay them to do that process?
Pay them to do what?
Host up a heck of a lot of forwarding nodes and then basically draw out the topology of the network.
Okay, well, you can probably draw the topology of the, that's a good question. You can draw topology of the network, but still you don't, like in Tor, you have the exit node, which is decrypting the final message, and they have some meaning, even if you're using SSL, but they still have some. In here, they wouldn't. They would just know the next destination, just the next destination, but they don't know who is there. Is it the end receiver, or is it just another node? They just act as a relay.
Yes, I understand that, but the idea was that they launched up a heck of a lot of nodes, and they actually became a large part of a completed circuit.
Okay.
But they had to do that out of pocket. The users weren't paying them for it.
Okay, that's just an interesting question. If you know more on this, I would love to work on this. I just don't have an answer at this moment.
Cool.
In your phase 2 example, you were talking about the message being broke, so from node A to node B, the message being broken up and carried through a bunch of other nodes. I'm wondering why you would do that, because if you're trying to preserve anonymity, you want to hide the fact that A is talking to B at all, not necessarily the content of the message. So I'm wondering what breaking the message up and putting it through this network accomplishes.
Well, first of all, if you're talking from A to B, and if there's, let's say, an ISP in the middle, they would know where the messages are going. And in case you break down the messages into chunks and send them through different relays as proxies, you get lost. You don't know who's. Basically, that's protecting identities of the messengers, because A and B, they're not nodes. They're original message and the recipient.
I think he was saying. If we imagine like a passive monitoring attack where we're sort of observing packets traveling the network, if you break it up and send it multiple ways, it's easier to monitor, I think. And he was asking if that's true.
Is that correct?
Yeah, sorry, kind of loud. Kind of. So in Tor, the anonymity is preserved because you have a route that's encrypted, so only the right person along the path can see that. And I'm assuming you're doing that in phase 1. So in phase 2, where you have it broken up, that just results in more nodes carrying traffic from A to B. And so if you have an attack where somebody is, by being several nodes along the path, able to statistically correlate traffic and stuff, I'm wondering what breaking it up, what it does. Because I'm not sure myself, I'm not an expert on this.
That's a good question. Yeah, it might be yeah, we need to model it more. Maybe it's enough just to use similar to Tor, just a few hops from nodes and finally getting to the destination. Eventually, the final node doesn't decrypt the message, so yeah, maybe that's not even worth it. It's something to model. We're not into phase 2 yet, so we're still building the first phase 1. So, thank you. Thank you.
So we have, does this one work? Okay. We have one more talk, and I'm just going to do a quick announcement in the loudspeakers outside to invite people in for the last talk, and then I'll introduce the final speakers. Good afternoon. I'd like to invite everyone in for the last talk of the day for Devcon3 in the main hall, Cozumel, and we'll start in a few minutes. So if you'd like to join us for the last talk, this is it. Thank you. Are you almost ready? This is Akasha unveiling the next experiment with Mihai Alisi and Marius Darila, right? Yeah?
Yeah.
Okay. Woo!
Yeah. Hola Cancun, what an
Hola.
epic DevCon this was. Can we agree? Let's give it up for Ethereum Foundation and everyone making this happen.
Yeah.
Thank you. So let me play this. Okay, let's see. Is this okay? Oh, let me try something else. Where's the mirroring? Use as a separate display.
No.
Technology.
Yeah.
Okay. So before we begin, I would like to ask how many of you have heard of Akasha before? Can we see a show of, whoa. Okay, that is impressive. And I'm just curious, how many of you have actually tried the alpha? Wow. Okay, so we have quite a few alpha veterans. Thank you for taking the time to play with the app. For those of you who haven't heard of Akasha before, as a word, it comes from Sanskrit, and it means ether. But it also stands as an acronym for Advanced Knowledge Architecture for Social Human Advocacy. And what we are trying to build is a peer-to-peer alternative in a world where the social media networks are modeled after the Napster architecture, where the user depends on a server or a server operator or an entity. And we want to tackle this problem from a different perspective using different technologies. So in a word, we want to showcase the potential of Ethereum combined with IPFS to solve all problems using new technologies. And the thing we want to achieve is a shared and persistent information commons that can help people that can help people regain their collective memory and freedom of expression, back from the claws of corporations that monetize each click and really everything. It's really bad. So to put it visually, the Napster web apps are, Napster-like web apps rely on the server admin or the server itself. And if for some reason the user does not comply or respect whatever the server operator wants, they lose access to the service. In the alpha, we took the hardest challenge we could find, which was to build a fully decentralized desktop app meaning that each user, when they downloaded and installed the Akasha application, they were actually installing bundled an Ethereum node and an IPFS node. So in the beta, thanks to hard work of the team, we will also introduce a fully functional web version, which will remove the need to sync with the chain. And the users will then rely on MetaMask or any other Web3 service provider like Status or Mist. And when we say that free speech is embedded in software, what we mean is that whereas the user can be kicked for whatever reason from the Napster-like web apps, on Akasha, the users are in full control over their identity and the content they are posting. So our story began on May 3rd, 2016, on World Press Freedom Day. And this is when we basically announced that we've been working for quite some time on the Akasha Alpha. It was a total shot in the dark for us. We weren't sure exactly what to expect, so it was kind of a test to see how it will be received. Among ourselves, before we released the website, we talked and we say, okay, man, what would we consider a success? You know, just to have some numbers. And Marius here said like 30 people in the first 24 hours would be cool. Roxana here, more optimistic, 50 people. And I was secretly hoping at around 100. 24 hours later, we surpassed 200 signups, which was like, whoa. And then in less than a month, we surpassed 2,000 people. So it became clear that we weren't crazy or that we weren't the only ones. So these numbers might not seem much at first, but it's worth mentioning that every single person that signed up for the alpha reached organically our website. So we just published blog posts, linked them on Reddit, or tweeted them. So what we wanted was to measure the real interest in the application, and we felt that paid advertising would attain those results. We would end up measuring the efficiency of targeted ads rather than the real interest in the application and idea. So fast forwarding until early 2017, 1 year after Ethereum, we launched the first public version of the alpha. And it was called Into the Ether. It was received very well by the community. And I suppose you guys also tried it. Hope you had a pleasant experience when you tried it. And basically in the alpha, we tried to have a basic functionality you find in a social network, which was to publish something, to comment on something, to read something, to vote, and to follow people. Combined also with things like, since we are using Ethereum, one of the side effects is that each identity is also a wallet, so people can also send resources to each other, and so forth. And after the release, this is actually a screen from the Akasha application, a comment. And on the first row, you can see that someone was like excited that there's a dApp that normal people can use. And for us, it was like exactly what we were aiming for. But I think the big point here was that with all these people, you and the others that might be watching this conference, we proved that it is possible. It is possible to have an application that does not rely on servers for people to communicate among themselves. And thanks to your playfulness and your time put into testing the application, we identified some bugs, and we also identified what can be done better. And Marius now is going to explain one of the lessons we learned in the alpha and that we applied in the beta. Marius?
Yeah, thank you. Yeah. So what is this? Yeah. I think all the alpha users got stuck at a given time in this loading screen. This was happening because of the way we used to load the resources. We were trying to get all of them at once. So if at a given time one of the resources would be unavailable, all of the other resources would have to wait for that one to become online before fetching them to the user. Yeah. So in the beta version, this was one of the biggest challenges we had to solve. We've done this by loading every single resource individually, as you can see in this demo. Yeah. So it comes with a great improvement on the UX side. Yeah. So enough with this.
Yeah. So another highlight of the beta is the first token experiment. In the alpha, we had AETH, which served as a placeholder token. And I just want to make something clear. This is there is just one token, which is this, currently nicknamed AETH. We are open to suggestions regarding the name. We want to avoid confusion with other projects like Ethereum, if anyone heard of it. Okay, and this is just an experiment to get the ball running, right? So we fully assume that we don't have all the answers, but we invite everyone to collaborate on finding them. So to give you an overview of how this token works, on the surface, AETH is in an ERC20 compatible token. It works pretty much as you would expect from an ERC20 token. You can send and receive, but there is a twist. You can lock it for a predefined amount of time, and this will give you something we call mana, which acts like a regenerable crypto fuel that can be burned inside the application. Marius will cover this in more detail afterwards. And essence is basically mana that is burned, and if the quality of the content is deemed as good, the authors and the persons interacting can consume this essence to mint new tokens in existence. And not lastly, karma is our experiment on the proto-reputation layer. And Marius now will give you a presentation of the token flow, of the states, and how everything ties in together.
So starting from the beta version, every user will have to burn a small amount of mana to interact with the application. So how do we get mana? A user can get some mana by locking his Akasha tokens for a period of time, during which he gets periodically the mana replenished. The mana used for the mana burned for doing actions in Akasha can be collected afterwards into two specific resources called essence and karma. Karma will serve in Akasha like some sort of proto-reputation, which will unlock specific features like creating communities and so on, which will require to be above a level of karma. The other one, the essence, it's interesting because this is the first idea which came to us to incentivize the users to create content on Akasha, because it can be consumed to mint new ERC20 Akasha tokens and be spent afterwards. Also, at any given time, the user can unlock their manified tokens, and afterwards it will go to the ERC20 state by passing to a delay time, which we call it a cycle. Yeah. So let's see a new basic flow. So we have the publisher, which posts an entry on Akasha. The readers afterwards can express their general feeling about the quality of the content by voting. After a voting period, the entry will generate a small amount of essence, which afterwards can be claimed by both publisher and the reader by specific use case. You can look on the flyers, yeah.
Yeah, but like when we were starting to feel good about ourselves, like, yeah, man, I think we're onto something here. Vitalik did it again. So then, just a few days ago, Vitalik published this entry. So he basically pointed out that there are more than just so a good token economic system requires more than just a way to insert units of that particular currency into circulation. And you know, this is quite interesting because following a couple of days, the media started to digest this information and started calling the tokens invented until this point as tokens 1.0. And you know, if you think about it, it's pretty accurate, since we are still barely scratching the surface of what can be done, and we are still trying to understand the basic pieces of the puzzle that make a good token work. And then things kept snowballing, and But by the end of the day, we had like this sort of stuff. It's like everything you need to know about cryptocurrencies. So, you know, 90% of startups in general fall. So maybe it would have been more accurate to say that with a poorly designed token, 99% of the token startups will fall. But to focus on the positive, the question of how do we get to token 2.0 started to take shape. And since Vitalik, thanks, started this, I figured that it's best to just show a short video of a short segment of a recent video done by Vitalik. So without further ado.
The nice thing about cryptocurrency, I think, is that it just makes it so bloody easy to create one of these economic mechanisms. You just write it up in code. That it just makes it really easy to sort of serve as an economic experimentation ground for doing these kinds of things.
And?
So, you know, the whole point of economic experimentation is sort of coming up with these sort of clever little tricks to sort of combine together incentives and sort of put things together in this nice way that gives people the incentive to do the right thing. And there's probably quite a lot to be done. It's just I think we're barely getting started.
We are barely getting started. I like to focus on that. Right? It's still just year 2 after Ethereum. And our approach to this thing, to maybe answering this question, is that just as Ethereum had during its frontier the Ethereum Olympics, where developers from around the world were invited to identify bugs, attack vectors, and basically, if you can break it, go ahead. And we'll learn from it, we'll become stronger. We invite everyone here and that's watching the presentation to join us in breaking and reinventing and re-breaking the token proposal. And basically with the AETH proposal and what we showcase today, we want to just get a prototype in the wild. And then in a sort of cypherpunk, inception-like fashion to iterate, co-create in the open, on Akasha itself. So we will use tags to coordinate, and later on, if we still have time, we will show you an actual demo of how this will work. But basically, what we want, or hope, is that if we approach things from this perspective, maybe people and startups can think of tokens as these dynamic adaptive systems which involve multiple pieces that you have to carefully put together rather than a graph going from 0 to the moon, right? So I think together, if we will tackle this question, we might reach some emergent shared understanding because no one has like the full idea of what is token 2.0, but 1,000 little half-baked ideas can come together in something completely new. And the cool thing about this is that, this is a quote I really like, is that the mind once stretched by a new idea never returned to its original dimensions. And if you want an example, just remember that in 2014, Ethereum had the Ether pre-sale, which led to around $18.5 million being raised to fund the development of the platform. And it was #1, as in the most successful crowdfunding campaign in the history of the internet. And now, a couple of years later, over $3 billion have been raised by companies using ICOs as a form of raising funds for their projects. So just one idea, huge impact. So now, the big picture of what we are trying to accomplish is like, we're not trying to compete with the big boys. I mean, they have billions of users, would be nice, but let's get real. We want to have a real alternative in place to keep them in check. And this is not like a paper or plastic bag choice. We want to offer people a fundamentally different choice when it comes to each person's digital sovereignty as human netizens. And I think we can all agree, after this beautiful Devcon, that watching history in the making is cool, but we think that writing the future ourselves is even cooler. So on this note, we invite everyone to join us in building together in this decade a better knowledge architecture for the next century. And we actually have all the tools, and we have like a pretty good idea of where things can go. And the future is not a place we get to visit. The future is a place we get to create. And I would like to announce that the beta signups are open for everyone that wants to participate and subscribe. Just go to akasha.world, insert your email, and in a matter of weeks, we will send you the invites, and we will start release the beta. And since I see we still have 2 minutes, I will now show you a demo of what the beta looks like. And this is basically the dashboard view, in which we have like different streams and different columns, which can be customized by the users. And here we add a column, which is a tag. And in this case, it's Crypto Olympics. So people can coordinate on the ideas, brainstorm. These are proposals. They can use the entries and the comment section as counter proposals or to discuss various ideas. And this is like an example in which is hola Cancun, hola Devcon, how it works to publish a comment. As you can see, the UI has changed quite a bit. Also in the backend, we basically are now looking at a completely rewritten decentralized application from dApp. So it would be more correct to call it Akasha like version 2. But since we started with the alpha, we will name it beta. And here on the left side, these are what we call boards for now, and basically offers like different windows into specific topics. So if we take the example of DevCon, one of the boards could have been like events, presentations, workshops, and people could have coordinated better rather than checking on Reddit, 10 Discord rooms, 1 Slack, you get the idea, 2 Gitters, and so on. So I would like to thank you all for your attention. And it's great being here. Hope to see you on Akasha soon. Yeah.
Thanks, Mihai and Akasha. And I wanted to thank everyone here, Devcon3 participants, presenters, panelists, sponsors, attendees, remote viewers, volunteers, event team members. And at this time, I would like to ask if there are any volunteers and Ethereum team members, please come up on stage so we can close out the show together. Casey, Hudson, anybody here? Everybody gone? Come on up. Come on up. Joe, come on up. It was not without effort to execute such a conference for our development community, but it was well worth it, and we'd like to do it again. And we don't have the whole, we don't have the team here, but I'd like everyone to come up who's been involved. Joe, come on up. And Vitalik, you're in the house. Come on up. Thank you all very, very much. Ethereum Foundation's Devcon3 2017.
Thank you so much. Thank you.
Woo.
Good one. Victor. Yeah. Nice. Hey. Nice. Hey. Nice. Thank you.
Thanks, everyone. Have a great night.